Hello, everyone. Good morning.
Hello, good morning. Let's wait for a couple of minutes for others to join in.
Yeah, sure.
Good morning, everyone. Let's wait a couple of minutes for others to join in, then we can get started.
Yeah, sure. Just a heads up. I couldn't completely free up my calendar because some things are going on which has put my team on fire. So I'll be, I have to attend a couple of meetings, so I'll be a little off and on in between. Yeah, sorry, apologies for that.
Since these sessions are recorded, maybe you can, at the end of the day or after this training, you can always look into the recordings and practice them later on, the parts that you
Sure, sure,
missed.
sure. Thanks so much.
We are expecting 25 to 30 people, so we'll give one more minute since this is day one, and then we can get started. Let us get started with the introduction to the course while others are joining in. Before we jump onto the course, I'm going to introduce this course to you. What exactly is this data science? What is machine learning? What are the tools? What are the techniques? What is the learning path? That is what we are going to discuss right now. After that, we'll get into individual introductions. After that, I'll give you the whole material that is required for doing the exercises in this classroom. I'm going to pass on the data sets, code file, material, and all the slides that I'm going to use in the classroom. Once everyone joins, I'm going to share all that with you so that you can download. Okay. We'll be using that in the rest of the 3 days. There is a supermarket called it's the third largest supermarket in US. Have you ever heard of this supermarket? Target is the name of it. There's one data science incident that happened in Target. What happened? They sent a gift pack to a woman. Along with it, there
Yeah,
is a car.
it was a purchase incident in which a lady was purchasing things, and based on the pattern of her purchase, the system got to know that probably she is in her first trimester. So they suggested some products which are related,
Yeah.
even though the lady herself did not know that she was pregnant.
Right. So, along with this, so the story goes like this. In fact, it was in the news also. What was the story? They sent one gift pack. Along with that, they sent one card. In that card, it was written, "Congratulations, you're pregnant. Take care of yourself, etc., etc." That woman got totally shocked because she did not reveal it to anyone that she was pregnant. Okay. Now, my question to you is, how come Target, a general supermarket like this, came to know that she was pregnant? How come? What they could have done in the background? Take a guess. How did they predict? Was it a random guess, or do you think was there some strategy
Um,
behind it?
it's like they try to consider the things like what during the first trimester, what usually buys, and according to
Right.
that, they planned it. Like
Right.
they
So basically, what happens is these retail companies they do something called customer segmentation. They take all the customers, divide them into different groups. These are called segments. Apparently, this woman is falling into a group where all the early pregnant women are falling. Based on whatever items that we are buying, we will be grouped or we will be made as segments. Okay. This woman is falling into a segment where all the early pregnant women are falling. And then to attract them, you can send some gift packs or offers or coupons. Maybe these are all the students who are going to colleges. This is a different segment. Okay. At a particular age group. These are all the employees, okay, who are at a particular age group, who are living in a particular city, who are having a certain income, who are having a certain expenses. Maybe we will devise a different strategy for them. Like that, we do the customer segmentation and then run all these marketing and sales strategies. Customer segmentation is the application for doing this customer segmentation behind the scenes. We use a statistical technique called decision trees. On day two, yes, tomorrow or day after, we are going to discuss what are decision trees. How are decision trees used for doing this kind of customer segmentation? How can you build these kind of strategies by using decision trees? The decision trees is that machine learning technique that will be used on this data. This is just one application of the data science. There are many more applications of the data science. All of you might be aware of them, so many of these data science applications. We are already part of few of the applications. Already some strategies are applied on us, isn't it? Some of the sales and marketing strategies, we are part of them. Now, if you ask me what is data science in general, the definition of the data science is data science in simple terms, data driven decision making. Data science is data driven decision making, building business strategies based on data analysis. By analyzing the data, you're building business strategies, removing the manual or judgmental error. Nobody is taking judgmental calls. We are going to use the data for deciding what should be the strategy, making use of past experience. Here, our past experience is historical data, using the historical data to build future business strategies. That is known as data science, simply data driven decision making. Data science is also known as data analytics. It is also known as data mining. It is also known as machine learning. It is also known as predictive modeling. There are so many terms that are used for the same context. If you look deep into all these things, you know what you will find at the end of the day? Deep in all this, the process is same. You take the data, isn't it? You take the data, you find the patterns in the data, use them for the prediction. You're going to predict what is going to happen based on the data. You build the strategies based on the patterns that you found in the data. So you may hear different terms, but at the end of the day, we take the data, we analyze the data, we use it for the prediction. That is what data science definition is. Data-driven decision making. Okay. There are three major types of skills that are required to become a data scientist. You should know the knowledge of database handling, analytics and machine learning, presentation and visualization or storytelling. These are the three major skills that one should have. If I have to explain them in deep, when I say database knowledge, you should know how to handle the data, database management, data blending, querying, data manipulations, ETL. I'm not really saying that you should be an expert database handler. I'm saying at least basic SQL you should know. Given two tables, you should know how to join them and how to create the final data. We should not always depend on someone else to prepare the data for us. That is the first skill set. The second skill set is analytics and machine learning. This is where all the statistics, mathematics, machine learning, all those things will come into the second one. Basic statistics, advanced analytics, predictive modeling, machine learning, deep learning, all of them are the second skill. If you look at the first circle and the second circle, there is a very small intersection, that's it. Whether you know this or not, you can still manage to learn this. The third skill is presentation skill, storytelling, data visualization, report design, insight presentation. People spend a lot of time in finding the insights here. But if you are not presenting in such a way that end user can consume, it will be very difficult. If we are just using some statistical jargons, then it may not be useful. We have to tell the story, whatever we found in the data. Clearly, we have to communicate using these visualizations effectively, clearly. These are the three major skills that you need to have as a data scientist. If you ask me what are the tools that I can learn, database tools, you're already aware of them. SQL, MySQL, Teradata, DB2, Oracle Informatics, Exadata. These are all database tools. Analytical tools, SAS, R, SPSS, Python, Weka, MATLAB, etc. These are the machine learning and analytics tools. You see this tool here, SAS. This used to be world's most widely used tool some time back. But in last 6-7 years, SAS has lost a lot of market share. There are actually two tools, both are open source, that give very tough competition to SAS. In all the companies, people are replacing SAS with one of these two tools. Can you make a guess what could be those two tools that have replaced SAS a great extent in a lot of industries? One of the tool is Python, the other one is R. These are the two tools that have actually replaced SAS at many places. Out of these two also, Python is the one that most of the industry is right now inclined towards because of the comprehensive nature of the packages that we can find in Python. Python is the most effective and the most famous tool right now. Okay, maybe for next 5-6 years it will stay. Okay. The presentation tools are Excel, Tableau, ClickView, and so on. Several presentation, Spotfire, several presentation tools are there. If you look at these circles carefully, by looking at our course contents, can you make a guess which one are we focusing? What is the scope of this 3-day program that we are going to discuss now? Which circle is in scope for us? Have you observed it? What are we going to learn? We are going to focus mostly on this one using the tool Python. So your company has designed this program in such a way that we are going to focus on machine learning using the tool Python. Okay. So what is the proper data science learning path? If you ask me, or if you ask me to suggest what is the best learning path, or even in future, if I have to learn all over once again, then I would be following this path, the most effective one. The first step should be don't get into machine learning, advanced machine learning applications directly. Start with a tool. Learn basics of tool. Tool can be anything, be it R, be it SAS, be it Python. Take any tool. Start with the basics of the coding. Not necessarily you should be a master developer, but at least some basics of data handling, basics of writing a code, basics of using a package like that. Few basic data handling skills are required in a tool. That is step one. Step two, there are some fundamental statistics, fundamental mathematics, which are easy to learn. They are not very difficult. We just need to recap the fundamental statistics at least. Mathematics, at least we can take it for granted. If a derivation is there, mathematical derivation, instead of understanding that exact theory of derivation, we can take it for granted. But at least we should be able to read the equations. That means at least till 12th class, if we have mathematics, then that is good eligibility, primary eligible. We are eligible to read all of them. Let's say if I say dy by dx, if you are not seeing this for the first time, if you have seen it somewhere sometime back while you are studying or something, then you will be able to follow some basic fundamentals which are easy to learn. That is the second step. The third step is there are some basic machine learning algorithms, classic machine learning algorithms, linear regression, logistic regression, customer segmentation algorithms. The fourth step is advanced or black box machine learning algorithms, random forest, boosting, etc. The fifth step is building these models efficiently with higher accuracy, with much faster execution, etc. That will be the fifth step. Obviously, within one sitting, we will not be able to completely go from step 1 to step 5 within one sitting. That is impossible. We have to learn few things, practice them, then go to the next phase. In this program, what are we going to cover? We are going to take a very basic introduction to Python. That means if you have Python knowledge earlier or any other programming school background, then it will be a quick recap for you. Otherwise, even if you do not have any Python knowledge, some of the commands that we are going to discuss, that will be useful. We are assuming that people are not from statistics background. So some fundamental statistics that are required, that will also be discussed. This is to bring everyone onto the same page so that we can understand the rest of the contents. Then very much in-depth understanding, very much in-depth discussion of regression, logistration, decision trees, along with the theory, along with the case studies, along with some of the practical issues that you will face while you are working on them, along with them what is the step-by-step procedure you must follow when you are working on these models. Everything will be discussed very much in depth here. And then an introduction to advanced machine learning algorithms like random forest and boosting will also be discussed in this classroom. So the main core focus will be on machine learning algorithms. Along with it, few more things also we will learn. So this workshop contains this 3-day workshop. Day 1, data manipulations in Python, basic statistics. Then the machine learning algorithms like regression, logistration, decision trees, cluster analysis. Then advanced machine learning algorithms like random forest and boosting. We're going to discuss each algorithm and what is the theory behind it, what is the application of it, what are some of the practical aspects. So with a lot of hands-on case studies, we're going to discuss all this. This is our 3-day plan. Any questions on this, anyone? Or any other questions that you have in general on data science? If you have any questions, you can ask me those as well. Right then, let us get into introductions. My name is Venkatareddy Konasani. I'm from Andhra. I used to live in Bangalore. I have shifted back to my hometown, Vijayawada. Right now, I'm in Vijayawada. I'm taking these sessions online from Vijayawada from past 1.5 year. I'm a trainer in machine learning, deep learning, data science, AI. These are all connected fields. I have given nearly 130 plus corporate batches of training across 25 different companies, nearly 3,000 participants I have trained. There are some companies that I very frequently visit. IBM is one of them. Every month I take one batch in IBM. From past 3 years, I'm doing that. Right now, until now, I have conducted almost 30 batches of training in IBM. Earlier, it used to be classroom training. I used to travel to Hyderabad, Bangalore, some of these locations, and then take the trainings in the classroom. Nowadays, it's all online batches. Nearly 800 people in IBM I have trained. Apart from IBM, I very regularly take trainings in Oracle. Almost every month, one batch in Oracle. Every month, one batch in IBM. I do that very frequently. Even for next 1 year also, it's lined up. Similarly, Bank of America is another company that I take a lot of trainings. There are other companies as well I travel to. I'm not a trainer or a teacher from the beginning. So I used to work as a data scientist. I have around 11 years of experience into data analytics. But teaching is my passion. So I quit my job. I prepared all the material. Then I started my training company in Bangalore, and then I started giving these trainings to corporates. So I'm into training from past 5 years. I used to work as a data scientist at HP. Before that, I worked for HSBC as a risk analyst. Before that, I worked for Citibank as a risk analyst. Risk analyst means like, have you ever heard of CIBIL score? CIBIL, that means the risk score that we have before applying a loan, we will be checked with CIBIL score. So somebody will be building a
Yes.
model to get that CIBIL score. So I used to work in that team, but that was for Citibank North America. I did my master's in applied statistics and informatics from IIT Bombay long back 2006 2008 that time. I have published two books. One of them is machine learning and deep learning using Python and TensorFlow. Previously, 4 years back, I published another book, Practical Business Analytics using SAS. Both of them are available on Amazon and Flipkart. Why am I here? I'm on a mission to make these statistics and machine learning easy, because a lot of people with a lot of motivation actually they start learning these machine learning concepts, but I would say there is a fault in the way that people are teaching them. Too many jargons are used. It is made to be really difficult. So I'm here to make it easy. Let us see, while we are concluding this course on day 3, I will check with you whether I have really made it easy or not. Okay, that is briefly about me. What we will do right now is we will go through the room, each and every participant. I'll also use this for attendance. Okay. So you tell me your name, your background and your experience, your team and your daily work. This will help me to fine tune some of the examples that we are going to discuss. Some of the discussion I'll try to give most relatable examples based on your background and your daily work. Your experience on Python tool, are you a beginner, intermediate or advanced? Do you have any prior working knowledge of machine learning? Based on this, I'll try to pace some of the concepts that we are going to discuss. And what is the main goal? What is the reason for attending this training? So everyone, you have to go through all these points. Try to introduce yourself on these lines. Okay. Whomsoever is ready, you can go ahead, unmute yourself, and then you can start your introduction. Please go ahead.
Yeah, hi, my name is Akshay Tyagi. I have around 14 plus of experience and entirely in database. Like right now, I'm working as an information architect. So majorly, like I work on like the SQL part itself and the providing solution for BI. So that's what, and I have like knowledge on Python. I'm planning to give a certification as well for Python. So that's what, and even for I've done the PG diploma in data science and machine learning in like a couple of years back, and I have also completed the data science professional certificate of IBM from Coursera. So that's my update, my intro. Thank you.
Okay, hi all. Very good morning. My name is Sunil. So I have close to 11 plus years of experience in IT. So currently working as data engineer and BI engineer. So currently working on Dundas, and I've worked on Cognos, Dundas, Tableau, and Power BI. And coming to the Python, so I must say that I've worked on Python for a couple of projects, including POCs and all. And machine learning, I've worked on 3 POCs within IBM, and I'm a IBM certified data science thing. So reason for attending this training is there's a lot of things to explore, and it's been way back, very long back. I've done the POCs and all, so it's kind of it's gonna be a refresh again for me. Yeah. So thank you.
So hi everybody, I'm Dipesh. I have more than 19 years of experience in IT and also around 1.5 years of experience as of teaching experience in Calcutta University. So my background is primarily that of applied mathematics and statistics. I am in IBM. I work in the ELM and AI applications team, and I have around 25 people reporting to me. My knowledge for Python is not much. It's beginner level. But when it comes to machine learning, I have worked on MATLAB, Octave, and Simulink, as well as on SPSS for different mathematical and statistical needs. I have also published 2 papers on ensemble learning and classification algorithms using uh, swarm intelligence and clustering algorithms, how they can be merged together. So essentially, it's like semi-supervised learning, if you may put it. Also, I had designed the recommendation system in my previous company, which was my own startup for network Netflix-like background. I am here in this training to ascertain that since we work in AI apps group, most of my team members would be requiring some kind of introduction or some kind of background into the whole of machine learning. I'm here to kind of understand what all we are covering here and whether I should be recommending this course to my direct reportees or something else, along with like our trainer has mentioned, the books that he has mentioned, one of those books are in my radar. So probably I'm in the right place and I'll be happy to find it out. Yeah, that's it.
Hi, my name is Kishore. I'm basically from DB2 DBA background, and I don't have prior experience on Python or statistics. Thank you.
Yeah, I'm Shiba. I have good experience on RDBMS. However, I'm pretty new to Python and no prior experience of working in ML. Reasons for attending this training is to get an overview of this ML and stuff like that. Yeah, that's it. Thank you.
Hi, this is Chaitanya Kumar. Hi, this is Chaitanya Kumar. I have around 10 years of experience as a big data consultant, and I'm working as a data specialist. With regards to Python or machine learning, I would quote myself as beginner. Thank you.
Hello everyone, my name is Priya, and I'm having around 7+ years of experience in Android development. So in IBM, I am working on an Android application part. Like I created some Android applications. Most of you guys use Mass 360 for that. So I'm working on that. And I have a little bit knowledge on the Python as I started some course from the Udemy, but it's a beginner level, you can say. And I don't have any prior working experience on the machine learning. So I just attending this course for my increasing my knowledge base on this Python and machine learning part. Thank you.
Hi everyone, I am Kesaka. I have around 4 years of experience in security domain and Java. I have some knowledge on Python, and in machine learning, I have worked on MATLAB, but it's very beginner level. And I wanted to explore data science and machine learning. That's why I have joined this stream. Thank you.
Hey, myself Shabna here. So I've been in this industry for more than 16 years, and I've been my last engagement has been as a cloud solution architect, and I work in a blockchain solution project in IBM. So I've been hardcore into development lifecycle most of the time. I don't have much background on Python or machine learning. And the reason for attending this training is I have done POCs. So one of our ideas got shortlisted and we have been asked to take it to a product level, and that requires some exposure to machine learning. So I'm just trying to understand kind of get some beginner level inputs there so that I can get going. Thanks.
Hello everyone, myself Mosam. I'm having around 7 years of experience mostly into the cloud development. In terms of Python, I am in the intermediate level and I don't have any prior experience on machine learning. And the reason for attending this training is to learn and those new and gain some insight on those machine learning. Thank you.
Hi, my name is. Sorry, yeah, please go ahead.
Yeah, my name is Sudhakar. I have around 12 years of experience, basically on backend engineer and cloud technologies. So the reason I'm here is I want to do a couple of POCs on one of the projects. It's basically kind of a requirement to do that POC. So that's why I want to explore this machine learning. I have a little bit of knowledge on Python, but I'm beginner to data science and machine learning. Thank you.
Hi, my name is Vidya. I have 15 plus years of experience in IT, and most of it, in fact, all of it is in the service management domain. I work closely with customers where we deploy the service management tools. And the reason for me being in this training is because we also work a lot with the data. So here the format of the data would be different, where we talk about the event data, the falls and all that. So I want to understand how to analyze it better. And with the introduction of the AI and machine learning into the tools, I want to understand this at a conceptual level, which is why I'm there in this training. With respect to my experience in Python and machine learning is concerned, I'm at a beginner level. Yeah, that's about me.
Hi, my name is Krishna Sri. I have a 3+ of experience in IT, mostly on the Java and React side. My experience with Python and machine learning would be a beginner. I'm very passionate to learn data science, so I joined this training for that.
Hi, this is Priyali Pudi. So I have just graduated from VIT Chennai in the field of computer science and engineering, and I'm a fresher into IBM. And before that, I was doing internship related to the Project Integro, and before that, I did an internship in a fintech firm where we had to measure the performance of portfolios of stocks against the industry benchmark. So have a little knowledge about the data manipulation. So my Python knowledge is intermediate, and I have keen interest in data science. And I'm also I'm a part of the growth and user engagement. So the reason I'm here is to, first of all, I have a keen interest in data science, plus to understand the usage data for the digital adoption. That's the main goal here. So yeah, that's it from my side. Thank you.
All right. Thanks for the detailed introduction, everyone. Based on your introduction, I can see that most of you are either at beginner to intermediate level in Python. Some of you already at an advanced level of Python. That means you will be able to handle Python for sure. And most of you are at a beginner level, and few people are at intermediate level as well when it comes to machine learning. So the audience that are expected are also from the same way, like when we are designing this course, we thought that people will be coming with the Python background, but maybe we have to assume people are beginners at the machine learning side. That's how the course is designed. Now there are certain rules that we have to follow when we are going through this session. Please make a note of this. This is a very long course, 8 hours a day, 3 days straight. There will be a lot of topics and subtopics. There are so many concepts to learn and absorb. Try to be prepared for that. Do not get distracted. It will be difficult for you to manage two things at a time. Let's say if you are working also, as well as if you are listening to this training, then you may not be able to run both of them parallelly. Try to plan your work in such a way that you push it towards the end of the day. Otherwise, you may not be able to do multitasking with this course. It may require your 100% attention for sure. Try not to get distracted by mails or messages, or try to push the meetings towards the end of the day. Do not skip hands-on exercises. The key to this course is actually doing the hands-on exercises. No matter how trivial an exercise looks, do not skip it. Try to give prompt responses to all the questions that I'm asking. The most frequently asked question will be, are you done with this code? Have you got the output? What is the output? Tell me the answer. So even though one person gives the answer, you should not stay quiet. You have to give your own answer in the chat window. Because in a classroom, I'll get to know who is doing, who is not doing just by looking at you. But here, everybody has to personally interact with me in the chat window. Okay. Now I'm going to give all the classroom files to you. However, let me just quickly confirm the attendance. So I have marked all of you are present. Is there any one person that I am missing? Please let me know. So because as of now, I can see 20 people in the classroom, and here I have counted 16. Quickly, can somebody send me the message if I'm missing anybody? Ram Prasad is marked as absent. Sampada Kulkarni, Archana Suri. Check this. Anybody who is here in the classroom but you have been marked as absent, please let me know. Deepiksha, Venkata, Suryananda Enduru, Shravani, Sukesh, Sukumaran, Venkata. Anybody? Naga, Ampavalli. Anyone who is here? Susmita Das, Vinita, Kirtana. That is it. These are all marked as absent. Okay. Remaining people are marked as present. If you are in the classroom, if you have been marked as absent, please let me know. If you are in the classroom, if your name is not visible here, then also you let me know. I'll add your name here because I'm going to share this with IBM team right now. They're going to do some adjustment based on this. There will be some people who are on the right now. Yeah.
Yeah, my name is is not on the list because I
Yeah.
was
Can you send me a message with your name and email ID? I'll just add it.
yeah,
Okay.
sure. Yeah.
Yeah. The question that I got is it mandatory to have a Windows laptop? It's mandatory to have a laptop or system access. Need not be Windows. It can be any system, but it has to be system, like, because we will be doing the hands-on exercises. Karthika, so you're here, but your name is not here, is it, Karthika? All right. Anyone else? Just one more minute for that. That's it. We will wrap this up.
If we sort it alphabetically, probably it would be easier for us.
So your name is here?
Yeah,
Deepesh?
my name is
Yeah.
here.
So just
Deepesh.
everybody will be focusing on their own name only. So that will be fine. Yeah.
I was just talking from the overall perspective.
Yeah. Fine. Okay. Fine. Actually, I tried doing that. These are all merged and all that. So that's why this is a kind of merged cell. Expand. There is some mix up in this file. Looks like this is a template that IBM is going to use and they are going to directly feed into a system. That's why it's like this.
Okay.
All right then. Thank you. Just give me 1 minute for me to send this to your team. What they generally do is they send people who are on the waiting list after looking at this attendance sheet sometimes. That's why it's mandatory to send it right away. Perfect. Now I'm going to give you all the classroom files, the data sets, the code files, the PPTs that I'm going through. I'm going to give you access to all of them. So I'm going to give you a link in the chat window. When you click that link, you will be able to access all the class files. Okay, let me give you that link. So when you go to the chat window now, just a second, yeah. So I have pasted a link in the chat window. When you click on that link, it will open a Google Classroom. So this is a Google Classroom environment where you will get access to all the class files. Okay. So what is a Google Classroom? This is one of the best platform for accessing the class files or for conducting online courses from a teacher point of view as well as a student point of view, participant point of view. It will be pretty useful. So once you click on that link, it will ask you to enter your Gmail ID password. Enter your personal Gmail ID and password. Personal Gmail ID password. Why it has to be personal? Because you can access this material even afterwards if you enter your personal Gmail ID password. Once you enter your personal Gmail ID password, you will be landing on this page. If you have landed on this page, that means you are inside the Google Classroom. You will be able to access all the class files. Okay. So once you are here, then I'll tell you how to access all the class material. But first, let us reach here. Are you here, all of you? Once you are here, send me a confirmation message in the chat window. Okay. Usually this step is not a very difficult step. Usually this happens pretty smoothly. If any case, if anyone is not able to reach to this place, please let me know. Because if once you are here, then I'll tell you how to access all the class files and all that. Yeah. Anybody who is not able to reach here, please let me know. Perfect. All of you are here. This is known as Google Classroom. A Google Classroom is a platform which is a perfect LMS platform, learning management system platform, where an instructor can upload the material and the participants can go through that material, download it, keep it with them attached to Drive, etc. So for the online schooling system, online college system, this is the one of the best available tool that is also for free right now. So if you go to classwork, at the top you see three options: stream, classwork, people. Click on classwork. Once you click on classwork, you'll be able to see all the material that I'm supposed to give you is already here. You have enrolled to this classroom. For the lifetime, you can access all this material. Even without having the link that I have shared. Tomorrow, if you want to access all this classroom after 1 year, after 6 months, or after 5 years, if you want to access this classroom material, go to your Google Classroom. This is lifetime access that you got to the material. Go to your Google Classroom. That's why I asked you to enter your personal Gmail ID and password. The reason is you should be able to access anytime in future. Classroom.google.com. You will be clicking on that. Then it will show you all the cards of the classrooms that you have enrolled previously. For me, it is showing Oracle, Deloitte, Oracle, all these things, different companies it is showing. But for you, it will show this IBM card. Click on that. And what is the link that you're going to click at the top? Three options are there: stream, classwork, and people. Click on classwork. These are all the class material. I have given you the course introduction, right? Those slides are here. Python basic statistics are first topic, second topic, third topic, and its material. Fourth topic and its material, PPT, code, and data sets. Fifth topic, topic by topic. All the material is here. For the rest of the 3 days, we will be using the material from here. We will be actually working on this classroom. Okay. For the rest of the 3 days, we'll be accessing the files from here. By the end of this course, anyway, you will develop some kind of comfort with this Google Classroom, and it's a very good platform for any online course. All right. With that, once we have all the class files, we are ready to get started. This is our first session. Before I get started, I would like to take, if there are any quick questions that I need to address, please let me know. All. There are no questions. Let us get started with some of the basic commands in Python and some of the packages that we will be using. We'll get a quick introduction to Python. Some people call Python as a language, some people call it as a tool. Both are correct. So it's a language as well as a tool, Python. Okay. We can use it like a tool. We can write the code at the low level as well. Great human readable syntax, well documented. The reason why we are using Python is right now it is used by many data scientists and developers around the world. So right now it is a red hot tool. So even a lot of the people in the industry, even our IBM clients might be asking us to work on Python. That's why we are using Python. How do you install Python in a local system? Python is a multi-purpose language. So there are so many IDEs where you can install and start coding in Python. After trying a couple of IDEs, I found one of the easiest way to get started. Anaconda is the software. If you install Anaconda, automatically it will install Python. Anaconda will automatically download important packages. It will set the class path. It will do all the admin job that is usually difficult in other packages, in other softwares. Anaconda makes it easy for you to get started with Python. If you are working on a different IDE, then well and good, no problem with that. But if you are a beginner, if you want to quickly get started with Python, you can install Anaconda on your personal system. It will automatically install all the softwares and the tools that are required for us. Within Anaconda, the Python work environment would be Jupyter Notebook. It is also known as Python Notebook. We will be working on Python notebook files. Okay. So a notebook file is a place where you have the code as well as the output, as well as the explanation, everything. It's a kind of mix of explanation plus the code. These are the notebook files that we are going to create. In this course, we are going to use the notebook files, Python notebook files, which are kept on Google Cloud system, Google Cloud. It is known as Google Colab or Collaboratory. Google Collaboratory is the work environment, or in short, you can call them as notebook files or Python notebook files. Apparently, the best part about this Collaboratory is zero configuration required, free access to GPU, easy sharing. So there are several advantages. GPU means graphic card, which will help us in executing some of the algorithms much faster. And once you create the files here, you can store them. They will be attached to your Google Drive. That means in future, if you want to access, you don't need to search anywhere. They will be automatically stored in your Google Drive. Okay. We will be using Google Colab for our work environment. Let us first check what is that Google Colab. How do you access Google Colab? Simple. You go to blank tab. All of you can try it along with me. Do this. Type Google, Google, COLAB, Google Colab. Okay. Google Colab and enter. The first link is Google Research, colab.research.google.com. Click on that link, Google Colab. If there is an advertisement, ignore that advertisement, then click on the first link, colab.research.com. For me, it shows previous Python notebooks, IPYNB, stands for IPython notebook files. For you, it may show a blank file like this. Can you see this window in your system? Let me wait here. Make sure that everyone reaches here first. Once you are here, at the right hand side bottom, you see new notebook. Check this out. I'm highlighting this here. New notebook, right hand side bottom. New notebook. You must click on new notebook. It will open a blank notebook file. It's called as Python notebook. So here is the blank notebook file that got opened. For me, it shows untitled 22. Maybe for you, it is untitled 0 or something. What is the process? Go to Google, type on Google Colab. It will give you a window on the right hand side down. You will have new notebook option. Then you should be able to open this new notebook. Once you are inside this new notebook, quickly send me a confirmation. New notebook open. All right. Look at this here. This is known as code cell. You can add another code cell by clicking on plus code. And you can also add a text cell inside a notebook. Text cell means some text can be written. Let's say if you go to the code cell, if I write x equal to 7, and then if I say print x, okay, x equal to 7, print x. If I want to execute this cell, I must click on this button or control enter. This play button can be clicked or control enter. As soon as you say this, cloud instance will be created. You will be allocated with some RAM and storage space, and then this command will be executed. Only for the first command, initialization is required. From the next command onwards, everything will work faster only. Now a RAM and disk space is given. A cloud is set up, cloud instance. From the next command onwards, let's say 67 into 89, if I execute, it gives me the result quickly. How do I add another cell? Plus code, like that. I have to click on this plus code to add a next cell, and then I can execute it using either control enter or this play button. Execute these two commands. If we are getting the output, that means our environment is set up. That means we are good to go. Please go ahead, execute these two commands, and let me know once you are ready. Let's wait for others to quickly confirm this to me. Are you able to give the input? Have you got the output? Input and output. Have you got this? Even when you are working on real-time projects, you must be mostly working on these Python notebooks only, data science projects that I'm talking about. All right. All right then. Let us understand some of the important packages in Python. I want to tell you one important information here. Please pay attention. When you are learning Python, you can use Python. Python is a multi-purpose language. You can use Python as a development tool or a development language. You can use Python to create ERP systems. You can use Python to create a website. You can use Python to create a software. Or you can use Python as a data science and machine learning tool for data science, data handling, data manipulations, model building, prediction. You can use it like a machine learning tool as well. You can use it as an alternative to C++, Java at some places, or you can use an alternative to R or SAS at some places. However, if you want to become a developer, if you want to use Python for development projects, if you want to become a Python developer, then your learning path is very different. The kind of packages that you have to focus on, the kind of functions and the commands that you have to focus on are very, very different. If you want to become a data scientist, the learning path, the packages, the functions, the commands that you will be focusing on will be very, very different. One has to know what I want to become, because Python is a kind of tricky language. You cannot directly go and learn Python unless until you know what is your end goal. If your end goal is to become a data scientist, then you have to learn a certain list of packages or a list of commands. If your end goal is to become a developer in Python, then there is a list of packages that you have to follow. I want you to help me in guiding people, especially who are not having any experience. They are doing this mistake. Sometimes people want to become a data scientist, but by mistake they joined a Python course, which is teaching them totally developer related content. Okay, so we need to be careful with that. In this program, we'll be focusing on all those packages, all those aspects of Python that are relevant for a data scientist. Okay. What are the packages that are used by the data scientists frequently? There are so many packages. Some of them are very frequent. NumPy, Pandas, scikit-learn, matplotlib, NLTK. These are the packages that are very frequently used. There are other packages as well, but these are kind of bread and butter. Without these, it's almost impossible to run any data science project. Let us get an introduction to these packages. The first package is a NumPy. Whenever you're doing mathematical computations, statistical analysis, you must need arrays, isn't it? Array computation. So how do you create arrays? Vectors, matrices, two-dimensional arrays, matrices. How do you run these mathematical computations very fast? Using arrays. Arrays can be created, arrays can be manipulated using a package, dedicated package called NumPy. So how do we work with arrays? For working with arrays, you need to have a package called NumPy. Import NumPy package as an alias np. I'm creating an income array here. Income equal to np.array, numpy.array. These are the values that are used in creating this array. Now this is an array. Once you have an array, you can avoid a lot of loops. That means if I want to multiply every number over here with this number, then what I have to do, I have to write a for loop. It will go to first element, then go to second, third, and all that. But if I have an array, I can simply say, take the array into this. Every element of array will be multiplied with these. Expenses will be another array. If income and expenses are of same length, then savings is another array, income minus expenses. So like this, we will be using a lot of array operations in future as well. But I'm just introducing this package name to you, NumPy. Later on, we'll get into more details of it based on the need. Let us do this quick exercise. I want you to go to the classroom once again. Classroom, Google Classroom on classwork. The first topic is course introduction, done with that. The second topic, Python basic statistics. Click on Python basic statistics. Python statistics data exploration. If I double click, it will open the notebook file. For some people, if you double click, you may not get this notebook file open. Then I am pasting this link directly. For those, if the notebook file is not opening, you can click on the link that I have shared, then you will be directly landing on this notebook file. What I want you to do is go through this NumPy exercise, execute one by one command, look at the output. Once you're done with this NumPy part of the code snippet, send me a message. Either you double click it, if it's not opening, then directly use this link to reach here. And then go to the NumPy portion of the code snippet, execute these 4-5 cells of the code. Go ahead, all of you. Once you're done with this whole cycle, send me a message. Once you're done, once you have the output of this printed, send me a message. Give me a confirmation. While you are executing this, if you are facing any issues also, you can ask me. If there are small glitches, we'll try to resolve them. All right. Before I move on to the next slide, are there any questions, anyone? Okay. Definitely, when we are working on data science projects, we'll be working on a lot of data. We may have to import the data. After importing, we may have to filter the data. Sometimes we may have to create new columns. Sometimes we may have to sort the data. Sometimes we may have to merge two data sets. Sometimes we may have to take the subset of the data. There are so many data manipulation operations that we may have to do, because raw data is not directly used in the final analysis, we may be doing a lot of manipulations for sure, starting from importing to the filtering to the creating new columns, etc., etc. Is there a package that can do all these things for me? Is there a package which has all these functions built in it? There is one package called Pandas. Pandas is the package that is having n number of sub packages and n number of functions that will help us in manipulating the data sets. Okay, for handling the data sets, there is one important package that is required, Pandas. Here I'm showing you importing example, but during this course we will be using many more functions of the Pandas in the upcoming sessions. Import Pandas as PD, package name, alias is given as PD, that's a general convention. Here from bank telemarketing, I'm importing a data set called bankmarket.csv. Pandas can be used for importing CSV files, for importing Excel files, for connecting it to a database and importing a table, for importing XML files, text files, nearly 40 different type of files. And this count is increasing day by day. You can import seamlessly. Okay. Pandas is very powerful. You can import the data from various places. In this example, I am importing from CSV file. pd.read_CSV is the function name. Mention the complete path along with the file name, along with the extension, and it will be imported, stored in this data set. I have stored this file on GitHub. So the file name is bankmarket.csv. Import this file, store it in bank. Here bank, it is a data set in the Python. It is known as pandas data frame. In here, in the pandas terminology, the data set, the data table that we call, something that has rows and columns. Inside Python, it is known as data frame. Okay. Bank is a data frame. Create this bank data frame. Tell me how many rows are there, how many columns are there in this data set. Number of rows and number of columns. So if everything works fine, you will be getting 45,211 rows, 18 columns. That is pretty quick. Looks like almost all of us are comfortable with Python. Very good. Are we done with this? Quickly stop me if you're still doing it. I'm going to go to the next slide. All right, perfect. If you want to create charts, if you want to create a chart, create a visualization, or create a graph, then which package is used? The package that is used for creating the charts or visualizations of the graphs, there is one dedicated package called matplotlib. There are alternatives as well, but these are kind of most widely used packages. Matplotlib. It has so many sub packages. It has so many functions that will help us in creating different styles of the charts, graphs, or the visualizations. Here, I'm creating X and Y, two arrays. X is an array of size 50. 50 values are there. 50 random values. Y has 50 random values. We can print and see. What I want to do is I want to draw a scatter plot. Have you heard of scatter plot? X versus Y. It will look like this, isn't it? This plot between X and Y. This is just the visualization. In the upcoming classes, what are we going to discuss? If the graph is like this, what does this mean? Is there a relationship between X and Y? Are they positively related? Are they negatively related, etc.? That is the discussion that we are going to have a little later. As of now, if you want to create graphs, charts, visualizations, which is the package for it? The package name is matplotlib. Okay. So here is the syntax. Import matplotlib as mp dot subpackage pyplot dot scatter is the function. Is this the only function? No, not necessarily. If I want to draw a bar chart, then I may have to read the documentation, find out what is the function for the bar chart. If I want to draw a pie chart, what is the function? mp dot pyplot dot scatter x comma y. Apart from this, you can give other parameters as well. If you are aware of this function, then we can give a parameter to change the size of these dots. Size. You can also change the color. You can add a title. You can add x-axis title, y-axis title. You can change the type of the marker, cross or plus or dot, like that. It is a very comprehensive sub package, and the functions also have so many parameters. But the basic mandatory parameters you have to give x and y for sure. Go ahead, go to your code file, create these two random arrays, draw a scatter plot. Yeah, done with it. Perfect. There is one more package, probably the most relevant, important package for us, scikit-learn. If you want to do any statistical analysis, if you want to build machine learning models, building, machine learning model validation, machine learning model fine-tuning, iterations, all the machine learning statistical model related tasks or the functions are embedded inside a package called scikit-learn. It is also known as sklearn. Short form is sklearn. Anything that is related to machine learning statistical analysis is part of this package. We will not be doing this exercise right now. It doesn't make any sense to us right now. But throughout the course, maybe rest of the 2.5 days, we will be totally working on this package most importantly. Tell me the package for creating arrays, working with vectors and matrices, matrix multiplications, etc. What's the package? NumPy. If I have a data set, I want to take a subset of the data. Can I use NumPy or do I need a different package for it? I need a package called pandas. Yes, I have imported the data. I have subsetted the data. There are two columns. I want to create a visualization for those two columns. I want to show the relationship between them. Or country-wise sales is what I want to show. Then I'll be using matplotlib. If I want to predict the sales, what is going to be my sales in a particular region or with a particular condition, if I want to do the prediction, if I want to build a model to predict it, what I'll be using? sklearn. These are some of the most widely used packages. There are other packages as well. But these are kind of very, very critical packages. If you are working as a data scientist, it's hard to avoid these packages. We will be working on these for sure. We'll be revisiting them again and again. I have just introduced the names to you. Sometimes we import the data. Right now we have printed the data to check the details, but not every time printing is a good idea. We should get the basic details of the data without printing, because sometimes the data has thousands of rows or millions of rows, or sometimes you may have thousands of columns. Even if you try to print, Python will give you a truncated output. So that is why there are some commands that should be on our fingertips that will help us quickly checking the basic details of the data that is imported. Okay. The first command is, let us suppose you have imported a data set called sales. This is a sales is a pandas data set, data frame. If I want to know number of rows and number of columns, how are we getting them right now? We are printing it. After printing a few, at the end, we are getting a message. But that's not the optimal way. You should say data frame name dot shape. Go ahead, import the sales data. Go to your code file. There is a location given to you. Sales by country is what you need to import. Store it in sales data frame. Use dataset name, data frame name dot shape, and tell me what do you see in the output window. What is the output that you got, and what does that mean? How do you interpret that output? So what do you see in the output? You see 998, 7. How do I understand this output? What does this mean to me? What is shape trying to tell me? It is telling me this data frame has 998 rows. It has 7 columns, rows and columns. I want to know the column names. And column types. Is it a numeric or a string object? I want to know, are there any missing values in each column? If I want to get the complete metadata details of each column, then what you should do is you should say sales.info. Shape is the property, that's why we don't need parentheses. Info is the method. So sales.info. If you write like this, you will get the complete column names, column details. So apply this, write this method sales.info. From the output, tell me how many columns are of numeric. Like some columns are numeric, some columns are string objects. What columns are numeric? Tell me which columns are numeric. Which columns are numeric? What are the numerical columns from your sales data? Will I also do it? I'm not doing it because I can see people are giving me answers pretty comfortably. That's why I'm not going into that. Run anyway. For me, first I have to import the package pandas. Let me execute this. Sales data. Okay. Now if I say shape, I'm getting the number of rows and number of columns. If I say info, what I'll see here is each column name and how many non-null values are there. And data type is numeric. The second one is object. Object means it has been stored as string or a character kind of thing. There are only two numerical variables. remaining all are string objects. Object here in Python data frame, it means it is a string kind of variable. Later on, we can change the data types and all that. So we want to store something as a particular type. Let's say I have date sold. I don't want to store it like a string. I want to convert into a date time variable. That is also possible. That is about the info. Usually, I suggest you to avoid printing the data. But if you still want to print and get an idea or have a snapshot of the data in your output, then what you can do is you can say sales dot head. Let's say sales dot head 10. Then 10 rows will be printed. Which 10 rows? First 10 rows will be printed. So if you go to sales dot head, the first top 10 rows will be printed. Even then there will be truncation. If you want to avoid the truncation, what you can do is you can avoid this print. Then it will display like this. However, if you do not give any number, by default it will be taken as 5. If you want to print for 10 rows, you have to give like that number. Usually, if you are using a print function, print tries to see whether I can print the complete output or do I need to truncate. Most probably it is going to show you few columns and truncate dot 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 and then show you some other columns. If you want to avoid that, you can avoid that print in the output. Then it will be printing your output. Usually printing is, it need to be avoided for large data sets. It may hang up your system. But if you want to see a snapshot, you can use either head, or if you want to print the last few records, you can always use tail, sales dot tail 5 or 10 or how many other records that you want. So these are some comments you should be having on your fingertips. Definitely shape and info. As soon as you import the data, all of you, look at this. As soon as you import the data, without fail, you should always check shape of the data and then info. Shape will tell you number of rows and number of columns. Info will tell you column by column details. Once you are done until tail, send me a message. All right. These are some of the basic commands. Without these commands, understanding it will be almost difficult for us to handle the upcoming sessions. But I think I can see most of you are pretty comfortable with this. Depending on the need, we will learn some more commands in the upcoming sessions. Let us understand some of the basic descriptive statistics. These basic descriptive statistics are used in exploring the data, exploring or describing or summarizing the data. For example, if I give you 10,000 individuals and their monthly income is what I have given you. Monthly income. Person 1, what is his income? Second, third person. Like that, 10,000 individuals, I have given you their monthly income. And I ask you to describe this data for me or summarize this data. Tell me in the summary, what are you going to give me? Obviously, you cannot print all these 10,000 individuals and their income in front of me, isn't it? You have to give some descriptive measures. Tell me what all you will give in your output. What are you going to describe? How are you going to describe, summarize this data? Think about it, everyone. What will you give me in your output? You will find the average income. isn't it? That is the first thing that comes to our mind. What else? Minimum income, maximum income. These are called descriptive statistics. What are descriptive statistics? They are used for describing the data. Descriptive statistics are used for describing, exploring, summarizing the data. Some of them we have already used, some of them may be new, but the thing is, the names, the technical names may be new to us. Central tendencies. We may not have heard about central tendencies, but we have used those central tendencies already. Average that you call here, it is known as a central tendency. Mean, known as arithmetic mean. Usually what do we call this as? Average. How do you calculate mean value? Tell me the formula. Mean equal to, what's the formula for calculation of the mean? Do you remember it? Sum of all the values divided by count. Summation xi divided by n. Sum of all the values divided by n. This is the first thing that we use for summarizing, but it is known as central tendency. In statistical terminology, it is known as central tendency. There is nothing that we need to really discuss hard about this mean because we have used it multiple places. Let us do a quick example on the mean. In Python, you don't need to really find sum and count separately and then do this division. You can directly use a function called mean. Let us take this data set, census income data. This is 1990 USA census data. It is available on their census website. We have downloaded it from there only. What I want you to do is store this data set in a data frame called income. There is a column called capital gain inside this. Capital gain is the column. One of the column name is capital gain. I want you to find the average capital gain. Here is the process. Income is my data set name. Capital gain can be accessed like this. You just need to write dot mean. Income, capital gain, dot mean. Store it in a variable called gain mean, or directly also you can print it and print gain mean or capital gain mean. Find out the capital gain mean. Tell me the answer in the chat window. How much is the average capital gain? Getting the answer as 1077.64. Confirm that. Is that correct? Verify this. Explore, so on, so on. All right. A quick GK question. Try to answer this question. If I ask you, what is the average monthly income of a person in India? Can you make a guess? If I take average monthly income of a person in India, how much do you think would that be?
Is it a kind of for every person, or is it only for people who are working?
All the people, average income, like from city to town to villages, east to west, north to south, everybody in India, if I take, what could be the average monthly income? Everybody.
Around 2,800 rupees.
2,800. Any other guesses? Some people are saying 30,000. May be correct, may not be correct. Any other guesses? What do you think it would be from your point? If you try to participate, may not be correct always. Anyone else? Any other guesses? Some people are saying it will be 15,000. Some people are saying it will be 10,000. Maybe correct, may not be correct. Some people are saying it is only 3,000. Some people are saying 10, some people are saying 16K, 15K. These are the answers that I have. But what if I tell you the average monthly income of a person in India? If you find that, you get to know that the average monthly income of a person in India is 75,000 per month, including all the villages, towns, and everything. If I tell you this is the answer, would you believe this? Or will you say, I don't know the right answer, but this cannot be the right answer?
No, I mean, it
Yeah.
cannot be the right
Data
answer.
issue.
Isn't it? Yeah, isn't it? But let us see how average is calculated. Look at this. Sum of everybody's income will be in the numerator. So it will have my income, your income, everyone else in the classroom, their income. We will have all our income in the numerator. Along with the, if we are taking everybody in India, along with the, who else will be there? There will be a person called Ambani. His monthly income will also be there in the numerator. I told every Indian. So, no. Plus,
By the way, his salary is 1 rupee.
along with the, who else will also be there? Who else? Along with Ambani. Adani will also be there. Monthly earnings or income will be there in the numerator. My income may be in thousands, your income in thousands, everybody's income is almost in thousands or lakhs. But Ambani's income, if you take his income, what will be his income? You want to take a guess? During the pandemic, Reliance share almost got doubled. So this person, when everybody was losing, he was earning a lot. He was nearly earning 60,000 crore per month. This was his earning in last 1 year per month, by the way. Adani is quite poor compared to Ambani. He was earning only 10,000 crore per month. Look at him. He has a reason to worry, even though he's earning 10,000 crore. He's earning only 1/3, 1/6 of what Ambani is earning. Now in the denominator, I'll be counted as 1, you'll be counted as 1, every one of us will be counted as 1, 1, 1. What will be Ambani counted as? 1 or 1,000 or 5,000, everything like that, or 1 only? Well, you're calculating
One.
One only.
One, and probably
Adani,
his family members as well.
yeah. Adani will also be counted as 1 only. Yes, sir?
Yeah.
Everybody will be counted as 1. In the numerator, we added a huge lump sum amount for one person. In the denominator, we still counting him as 1 only. Sir, no. Definitely, there will be some data points like this in the original data. Whenever you take any real data set, there will be always some data points that are very far away from the rest of the data points. Do you agree? You cannot expect the data to be only in certain range always. In reality, there will be some data points that are very, very far away from the rest of the data points. That is the true
Yes,
nature of the
outliers.
data. These are known as what? They are known as
Outliers.
outliers. When there are outliers present in the data, mean, the average that we know, will be pulled. Mean will be influenced by the outliers. Mean unnecessarily shows it to be a really high value. That is the reason why in India, if you find the mean salary, average salary, you will find somewhere in the range of 75,000 to 80,000. Because around 1% of the population in India, their earnings are in crores. Obviously, there are some outliers in the data. If you just have the outliers as it is, if you calculate the mean will be very much influenced by the outliers. It shows a really high value, but in reality, it is not a true center. If you look at this data, for me, this data, everything looks between 1 and 2. If I find the mean, I expect it to be around 1.4 or 1.5. But when I calculated the mean, to my surprise, I got it to be 2.5. Why?
Because
Might be,
9 is an outlier.
because there is one black sheep, there is an outlier here. Statement number 1. Look at this data. 90% of the data points over there. 90% of the data points are less than 2. Is that a right statement? 90% of the data points are less than 2.
Correct.
Second statement, mean is 2.5. Don't you think this is sounding like a contradiction? On one side, I'm saying almost all the data points are less than 2, 90% of the data points are less than 2. But on the other side, I'm saying average is 2.5. Why is this contradiction happening? What is the cause of this contradiction? Why there is this discrepancy? Why is this contradiction? Because there are outliers. Outliers are very dangerous. They turn our analysis upside down. We are going to have a detailed discussion on outliers a little later. As of now, I have just introduced the name only, but there will be 3-4 more places where we will be discussing about them very clearly. Then what is the alternative? Is there any other average? Because mean is the only average that I know until now. There's one more average called median.
Median, yeah.
Median is also average only. Just like mean, median is also average. But the way we calculate it is different. We take the data and then we sort the data, sort it. Take the middle value. You take this data, in the middle there can be anything, but after sorting, you take the middle value. The middle value is 1.4. This is called median. The positional measure, right in the center is what we are taking. Below median, 50% of the data is there. Above median, 50% of the data is there. Median is an alternative to mean. Median and mean both are averages only. Median is very effective when you have outlier. Look at this. Instead of 9, if I have 99 here, can you tell me the new median? Will it be 1.4 or 14? Will it still be
It will
1.4?
still be 1.4 because it is
1.4 only.
dependent on the number of values that merge or which are actually 1.4. Changing one particular value to anything will not change that metric.
Change that. Yes. Even if I make it 999, what will be the median value?
It still remains the same.
It will still. So can I say median is not impacted by median?
So it's a central tendency metric.
Values. It's basically the positional, like the numbers, and you take the positional value of it. So it's not based on the values. It's the position of the.
So we can safely say median is not impacted by outliers. It says no matter how large
It's a
they are.
central tendency your attribute.
Whereas mean, if I change from 9 to 99, mean will change, isn't it? Very significantly. If I change from 99 to 999, mean will change significantly, isn't it? Right now, mean is 2.5. If I make it 99, mean will be moved a lot, isn't it? If I make it 999, mean will be moved a lot, whereas median is not. So in real world, how do you use mean and median? This is the process that you have to follow. Until now, we have a habit of calculating mean only. When somebody asks us to calculate the average, we just calculate the mean. What I want you to do is, from here on, always calculate median as well. Along with mean, you must calculate median. Look at the value of mean, look at the value of median. If there's a huge gap between them, there's a huge difference. How do you interpret it? What is the hint that you're going to get? There's a huge difference between mean and median. What is the first hint that you're going to get?
There are outliers.
Outliers in the data. This need to be drilled down, isn't it? This need to be drilled down. Look carefully. Agreed or not? At a later point of time, I'm going to tell you how do you detect outliers. How do you handle outliers? How do you clean the data when you have outliers? Those are all upcoming. But have you got a hint right now? Look at the mean value, look at the median value. There are better ways of detecting outliers. This is going to give you a hint. Now going back to
capital gain. You told me the capital gain, mean value of capital gain is 1077. Can I trust this on the face of it right now after learning about median and all that? Is it safe to think that the average capital gain is definitely 1077? Almost everybody is having this much capital gain. Is it safe to trust like this? Or what should I do? Can I trust this? Then can I say really the average capital gain is 1077? Can I say I'll calculate the median? Maybe around that, maybe 1100, maybe 1000, maybe 1200. If it is around this, then I would say it's safe. 1 or 2% difference, 4% difference, it's fine. But if there is a significant difference, there's a huge difference, then there are outliers. We look at. Can you tell me is the median, the capital gain, 6,000? Capital gain. How is that? Zero? Are you sure? Zero? Median is zero, mean is 1000. Mean is 1077, median is zero. By looking at this as a data scientist, what is the first inference? What is the first point that you are going to make down? What are you going to note down? What is the first point? There are outliers. We need to drill down and do a detailed analysis of this particular column. Can I directly take as it is and run it in the analysis? Can I create the graphs and all that? No. This need to be re-looked upon. We need to further look at this data, which I'm going to tell you what are the other measures. That is the story of mean and median. That is why in India, if you take the mean income, it will be 75,000 per month. If you take the median income, that will be 8,000 per month. Let us suppose I am planning the welfare schemes for Indian people. Do I need to consider 75,000 per month, think that everybody is anyway earning a lot? Or do I need to consider 8,000 per month? Should I consider mean or median when I am planning the welfare schemes, pension schemes, all these things? Definitely median, isn't it? Remember, median is 8,000. What does this tell us? It tells us that 50% of the people in India, it's a sad situation. 50% of the people are actually earning less than 8,000. Makes sense? Is that a right statement? If median is 8,000, that means center value is 8,000. Is it fair to say 50% are earning less than 8,000? Yeah, that is the current situation. Based on this only, the government comes up with schemes and all that. So when the government says we are giving 1,500 per month as a pension scheme, or we are giving 1 acre, we are giving like 20,000 per year. So they are actually counting this 8,000 per month as the income, and they are saying we are giving 20% or 30% of whatever income that they could generate. Which is kind of, from their point of view, it's a fair job. That is the story of mean and median. Is it clear? In future, are you going to work with both mean and median? The only final conclusive point that I want to tell you is don't just look at the average. Whenever somebody says average, we have a habit of looking at mean only. Always have a look at a value of the median. 1 or 2% difference, 3% difference is fine. It's okay. You don't need to have exactly same mean and same median. But if there is a significant difference, if there is a huge difference between mean and median, then you know that there are outliers in the data. Any questions on this? Anyone having any questions on whatever we discussed?
It's clear for me.
Let's do one thing. Let us take a quick tea break and we will be back after the break. We will continue this discussion once again. Just before the break, if you have any questions or any general questions, if something is not working quickly, let me know. We'll try to fix it before going. All right. Right after the break, if you have any questions, I'll take them. Then we will move on to the next topic. Let us move. Let's meet at 11:35 a.m. and then continue this discussion. Okay. I'll see you the other side. Welcome back, everyone. Once you're back at your desk, send me a message. So back at your desk. Are there any questions from whatever we discussed until now? The questions? New story. Where is all of it actually? Let us suppose that a person wants to cross small river. He doesn't know how to swim. He gets into a very deep water, he may get drowned. There's another person who is standing by the side of the river. So he asked him, what is the depth of the river? Because I had to go to that side. This person told the average depth is 4 feet. So very smart people to start from by what okay. I have adjusted the microphone. Can you check it now? Is the voice clear? Is it better or yes? Shall we continue like this? Yeah. Okay, perfect. Let's go ahead. This person want to cross from this side to this side, but he doesn't know how to swim. He asked him what is the average depth of the river. He told 4 feet. And he asked him what is the mean depth, what is the median depth. He told him mean depth is also 4 feet, median depth is also 4 feet. He is around 6 feet tall. He thinks that 4 feet he'll be able to cross the river. He starts crossing the river. Do you think this person, is he going to reach to point B or is he going to drown? What do you think is going to happen? The average depth is 4 feet. Doesn't necessarily mean everywhere it will be exactly precisely 4 feet. There will be some points where it will be less than 4 feet. 1 feet, 2 feet or 3 feet, something like that. There will be some points it will be less than 4 feet. There will be some points where it will be 5 feet, 6 feet, 7 feet, 8 feet, 9 feet, 10 feet, 12 feet also possible. So definitely this person, he is just 6 feet tall. He may not reach to point B. Here what I'm trying to tell you is looking at the center always doesn't mean you're getting the complete picture. Sometimes we may have to look at the dispersion around the center, the spread around the center. Another relevant example could be, let's say there are two companies, company A and company B. Out of these two companies, when you look at their profit after tax in the last 15 quarters, the profit after tax for company A is $15 million. For company B is also $15 million. Both are having the same average value. If I want to invest in a company that is less risky, I want to hold it for a long term, which company I should invest in? Looks like both companies are almost giving me the same profit from past 3 years. However, if I go to the original values, these are the results of company A. Average is $15 million. Company B, average is $15 million. If I ask you to invest in a company which is less risky, hold it for a long term, which company do you think we should invest in? Is it company A or company B? What do you think we should be doing? Shall we choose company A or company B? Which one is beneficial for us? Very less risky, holding it for a long term. Most of the people are saying company B. The reason could be this: both company A and company B, both of them have $15 million, that is company A, $15 million, that is company B. Both of them have the same center value. However, for company A, sometimes the profit is way more than $15 million. Whereas, and sometimes it is way below $15 million as well. Very much higher than 15 in some cases, very much lower than 15 in some cases. Whereas for company B, sometimes or almost in every occasion, the profit is sometimes slightly higher, sometimes slightly lower, but most of the cases, the profit is in and around $15 million only. If you are looking for a company that is very less risky, we would rather go with a company that is performing consistently around that $15 million mark. We'd be choosing company B. However, both of them have the same average. So average doesn't give us any idea on the dispersion in the data, on the spread in the data. If you want to quantify the spread, if you want to give a number that A has higher spread, B has lower spread, lower dispersion, what is that measure that will quantify the spread in the data, dispersion in the data? Is there any way of quantifying it and saying A is having higher dispersion, B is having lower dispersion, and this much is the amount? There is a measure called variance. Variance is the measure of dispersion. How variance is calculated? Take the original value, 43, 44, 0 and so on. Take the mean value. Then take value minus mean. Value minus mean. 43 minus 15, 28. 44 minus 15, 29. 0 minus 15, minus 15. 25 minus 15, 10. Take value minus mean. Similarly, for company B also take all the values. Take the mean. Let me call this as y bar. Value minus mean. 17 minus 15, 2. 15 minus 15, 0. 12 minus 15, minus 3. These are called deviations from the mean. These are all the deviations from the mean. Look at this. Higher dispersion means what? Higher deviations. So can I simply take the sum of all deviations to get an idea on the dispersion? Can I take sum of all these deviations? That will tell me how much dispersed the data is, or taking sum is kind of tricky. Can I simply sum up all these deviations? I cannot use the direct summation. The reason is few deviations are positive. Few deviations are negative as well. So they may cancel out. So instead of taking summation, I can take either absolute value or I can take the squared value. Usually squared value is mathematically convenient. 28 square, 29 square, minus 15 square. These are all the squared deviations. Then take the average of all these squared deviations. How do you find the average of squared deviation? Average means summation of all the values. 7 minus x square whole square divided by count. This is known as variance. Variance for company A is 352. variance for company B is 4.9. How do you calculate variance? Xi minus x bar whole square. Why are we squaring it up? Because few are positive, few are negative. And sum of all of them, sum divided by count. This is variance, which means apart from giving this mean value only, if I would have given variance value, company A 352 is the variance. For company B 4.9 is the variance. Do I really need to show you the data, or you can directly tell me which one is less risky for long term? Tell me from this example point of view, which stock is less risky for me? The company that has, when do you say it is less risky? You find the variance, the company that has lesser variance, that is less risky. Yeah. What if I am investing in options, derivatives? I want to show only for short term. I want to buy now, sell it at the end of the week with a small profit, or maybe sell it at the end of the month with a small profit margin. I want to do trading. I'm not an investor. I'm not looking for 10 years down the window. Maximum I look for is 3 months or 4 months or 1 year maximum. I'm a trader. I'm not an investor. Then which company I should search for? Which company I should invest in to enter and exit quickly? Obviously, I will go with company A that has higher variance because that will give me multiple entry and exit points. So it always depends on the problem statement that you are handling, whether high variance is preferred or low variance is preferred. That should be decided based on the problem that you are handling. We cannot always say less variance is good for us. Sometimes you may want versatility, then you may go for high variance. Sometimes you may want consistency, then you go for low variance. That's what variance is going to tell us. What does variance do? Variance quantifies the dispersion in the data. This gives us a number. Higher the number, higher the dispersion. However, in all this discussion, there is only one counterintuitive point. Why did we do the squaring? Looks like if you do the square, it looks like unnecessarily we have inflated the whole value. That is why we can consider an alternative measure which is derived from here only. Either you can consider variance. If that is not preferred, you can consider the square root of variance. Because if value is in dollars, variance is in dollar square. If you are not comfortable with this, you can take the square root of variance. Square root of variance is known as standard deviation. So when you are comparing two variables, either you can compare their variance or you can compare the square root of variance, which is pretty much the same, standard deviation. So standard deviation is nothing but square root of variance. Both variance and standard deviation, they try to quantify the dispersion in the data. These are not two different measures. This is just one measure. The other one is just the square root of variance. That's it. What is the use of this measure? This will help us in quantifying the dispersion in the data. These are all called data exploratory measures. They may not help you to build a strategy directly. They'll try to explore the data. They'll help you in exploring a particular column. Is it having high variance or low variance? So the type of data exploration in the step, we will be using variance and standard deviation. Even in the other upcoming algorithms that we are going to use, in that, in some of the formulas, these formulas will be used. We should have, these are kind of fundamental concepts. If we have the knowledge of these, later on we'll be using them in some advanced topics. Okay. That is the story of variance and standard deviation. However, that's just the theory. Let us see how that can be calculated on a given data set. I want you to import this data set called online retail sales data. Import this. There are two columns called unit price and quantity. For both the columns, calculate the variance and standard deviation. For unit price, variance and standard deviation. For quantity, variance and standard deviation. Calculate these numbers and tell me the answer in the chat window. Variance of unit price 14,569 point something, 120 point something. Quantity 83,695, 289. Either you compare variance values or you compare standard deviation values when you want to check like consistency of two populations. Done. As it is, I told you, these are not the measures that will be standalone we will be using to build the strategies. Along with these measures, we are going to, these measures will be useful in understanding the upcoming concepts. Somewhere variance and standard deviation, these formulas will be used. Please remember, whenever I show you any formula in this course, you don't need to memorize any of the formulas. Throughout this course, no need to memorize any of the formulas that have we discussed right now, and even the upcoming formulas also, no need to memorize or recollect any of these formulas. We just need to understand, that's it. We don't need to really memorize all these formulas that are given for the calculation of these measures. The next part of the story. Imagine there is a student who attempted an exam. Along with him, there are 10,000 other students who attempted this exam. This particular person got 75 marks out of 100 marks. Is he doing a good job or not? What do you think? Shall we say that you did a good job, you got 75 out of 100, or is it not doing a good job? Now, when we see this output, there can be two scenarios. In scenario 1, with 75 marks, it may happen that he may have outscored 90% of the people. 9,000 people scored below 75. 90% of the people are below him. Only 1,000 people are above him, which is like 10% or only are above him. That is scenario 1. In that case, which percentile he is standing at? Which percentile? 90% are below him with 75 marks. With 75 marks, he is standing at what percentile in scenario 1? Tell me. Below me, 9,000 people are there out of 10,000. So he is standing at which percentile? Think about it. A person scored 75 marks, maybe some X marks. And below him, 9,000 people are there. Out of 10,000, 9,000 people are there. 90% are below him. So he is called as, he is standing at 90 percentile. How many ever, what percent of the people are below me, that will decide my percentile. Okay. Below this, 90% of the people are there. That's why he's standing at 90 percentile. That is scenario 1. He's doing a good job because he's got 90 percentile. In scenario 2, it happened that with 75 marks, the paper was so easy that he outscored only 1,000 people. Remaining 9,000 people scored better than him. 90% are above him, only 10% are below him. So with the same 75 marks, this is scenario 1. With the same 75 marks, he is standing at which percentile in scenario 2? Below him, how much are there? Only 1,000 are there, 10 percentile. So if he's in scenario 1, we'll say you're doing a good job because you outsmarted 90% of the people. If he's in scenario 2, though you got 75 marks, but you outscored only 1,000 people, you require a lot of improvement. Sometimes the standalone number doesn't really matter. How many marks that you got doesn't really matter. What really matters is what is the relative position of this when compared to the rest of the population. Is it really higher comparatively? Is it really lower comparatively? Standalone X may not really help us in the final decision making. We may have to compare it with the rest of the population. For comparison, we use percentiles. Percentiles is a very useful measure that can be used for comparing for the rest of the values. Take any value in the data, compare it with the rest of the values, look at its relative position. Percentiles are very heavily used in exams, in the schooling and college system. But we can use percentiles in some other data analysis as well. Pretty useful concept. Let us understand what are percentiles. Percentiles can be calculated for any numerical data. Let's say income. I have the data of income or expenses. Any numerical data, number of loans, monthly utilization, credit score. These type of numerical variables, for them I can calculate the percentiles. So in Python, when you ask for percentiles, Python will actually take the data, calculate the percentiles and give you the result. In 2 columns, it will give you the result. The first column is percentile, whatever is the percentile that you asked for. The second column is value, variable value. The variable could be income, variable could be expenses, loans, or monthly utilization or credit score, any numerical variable value. You can ask for 0 percentile, 10 percentile, 20 percentile. What is the 30 percentile value in the data? What is the 50 percentile value? What is the 70 percentile value? You can ask for what is the 75 percentile value, 90 percentile value, 100 percentile value. You can ask for all these numbers. If you ask for 10 percentile value, let's say income is the variable, and you want to know the 10 percentile value of income, then what Python will do? Python will rearrange the income from maximum value to the minimum value. It will find a particular point. It will find that income value where below it 10% of the data is there, above it 90% of the data is there. It will find that X and give you that value in return. Let's say $2,000 is the point where below 2,000, 10% of the people are there, above 2,000, 90% of the people are there. If you ask for 20 percentile, similarly, it will find that particular point. Below it is 20% of the data, above it is 80% of the data. Maybe something like 2700 is the point where below it is 20% of the data is there, above it is 80% of the data. Like that, Python is going to calculate and give you. If you ask for 0 percentile, what it will return? Tell me. Think about it. For any variable, if you ask for 0 percentile, it has to find a point below it, there is nothing. Below it is 0. Everything is above it. What is the 0 percentile value? For any variable, if you ask for 0 percentile, what will be given to you in return? I have given, let's say, income. And I asked for 0 percentile of income. What will you get in the output? It will find that point in the income. First, it will arrange the income from max to min. It will find that point. Below it, there is nothing. Above it is 100%. Which means what point will be returned to you? If you ask for 0 percentile, it will give you the minimum value of income. Agreed or not? A minimum value of a variable. Is that correct? Think about it. If we ask for 0 percentile, we will get the minimum value in return. Whatever is the minimum value. If we ask for 100 percentile, what will be given to you in return? What is that particular point where below it is 100% of the data, above it is there is nothing. Above that there is only 0% of the data. Below is 100, above is 100. Below is 100, above is 0. What will be returned to you in the output? It will be the max value. So 0 percentile minimum already we know. Usually we know what is the minimum value, but it is actually known as 0 percentile. Maximum value is 100 percentile. Can you tell me out of these the other percentiles, We also discussed one more percentile with a different name. Can you spot it? Out of the ones that I have listed here, we discussed one more percentile but with a different name. Like the way 0 percentile, different name is minimum. 100 percentile, different name is maximum. What is the other percentile that we discussed already in this classroom? Think about it. What is the other percentile that we already discussed? 50 percentile. Have we already discussed this with a different name? Think about it. What is 50 percentile? What is that point where 50% of the data below it, 50% is above it? Have we already discussed? What is the point where 50% below, 50% above? Is it mean or median or both or only mean or only median? What do you think is the answer? The 50 percentile value, what is it? It's strictly median, isn't it? Median is the true center. 50% is below, 50% is above the median. Similarly, if you ask for 10 percentile, Python will calculate that point where 10% below it, 90% above it given to you. 20 percentile, 30 percentile, like that. Whichever percentile you ask, if you ask for 90 percentile, that particular point will be given to you 90% below it, 10% above it. And these percentiles are used in further understanding the data. We're going to see with a case study, how do we really make use of these percentiles and this percentile table? How is it really beneficial for us? Let us actually take a case study and then try to understand this further. Do you remember? We have one variable called capital gain that we have already started working on it. Income data has capital gain. If I want to find the percentiles of the capital gain, here is the process. Data frame name, variable name, any numerical column, dot, quantile is the function. QUAN, as in like quantity, quantile. 0 means 0 percentile. 0.1 is 10 percentile. 0.2 is 20 percentile. 30 percentile. 40 percentile, like that. 60%. You can give any percentile that you want. This is 60 percentile, 70. If I want 75 percentile, how do I give it? What should I mention in this quantile function if I want to know the 75 percentile? What is that point? Below it is 3/4 of the data, above it is 1/4 of the data. 75 percentile is what I want to fetch. I would give 0.75 here. 80 percentile. 1 means 100 percentile, which is like max value. Then it will find these values and give you the result. Then we may have to go through the results and interpret the results, get the inference about the variable. Go ahead, create this table, percentile table. So in the output, you will have two values. One is percentile, whichever percentile that you asked for. The other one is variable value. Variable value is capital gain value. So you asked for 0 percentile, 10 percentile, 20, 30, 40, 10 percentile, 20 percentile, 30 percentile, 40, 50, 60, 70, 80 percentile, 90 percentile, and 100 percentile is what you have asked for. Once you have the result, we'll discuss the output. Have you got the result, everyone? Okay, look at your output and tell me what is a 0 percentile of capital gain. What is the 0 percentile of capital gain? It is given as 0. What do you infer from here? If the 0 percentile is 0, which statement can you make here? Minimum value of capital gain is 0. There are no negative values in capital gain. Is that a right statement? Yeah. 10 percentile is how much? 10 percentile. Well, in your case, that is also 0. If 10 percentile is 0, we can make two statements. Statement number 1 is 10% of capital gain is 0. This is for sure. Yeah. 10% of the capital gain is 0 for sure. Maybe remaining 90% is greater than 0, but this we are not sure. Can we make any commitment? Can we say rest of 90% will be greater than 0? Only 10% will be. Right now at this point, we can only talk about whatever we have seen. Look at this. First statement is 10% of the capital gain is 0 for sure. Why am I so sure? From minimum till here I have seen. Is that first statement correct? 10% of the capital gain is 0 for sure. Yeah, check this out. First statement, 10 percentile value is 0, which means 10% of the capital gain is 0 for sure. What is the second statement? Maybe remaining 90% is greater than 0, but that we are not very sure, isn't it? We have to check, then only we'll get to know. Can I commit that remaining 90% is greater than 0 for sure? No, not sure. What is 20 percentile value? 20 percentile value is 0. Tell me the first statement. Write down the first statement. If 20 percentile value is 0, what are you going to write in your first statement? Or maybe you can even put it as less than or equal to 0, which covers both equal to. 20% of capital gain is less than or equal to 0. In future also it covers equal to as well as less than or equal to. This is for sure. What is the second statement that I'm going to make? Maybe remaining whole 80% is greater than 0, but this I cannot be so sure. This I'm not sure. Similarly, I look at 30, 40, 50, 60, 70, come to the 80 percentile value. Tell me what is the 80 percentile value? What is the 80 percentile value? 0. What is the first statement? By looking at 80 percentile as 0, what is the first inference that I'll draw? The first inference we must be drawing 80% of capital gain is less than or equal to 0 for sure. Maybe remaining whole 20% is greater than 0, but this I cannot be very sure. Not sure. The last one, this one I want everyone to participate. We are nearing the end of the discussion. 90 percentile is also 0. What can I make as a first statement? 90% of capital gain is less than or equal to 0. In our case, it is 0. This is for sure. If I ask you why are you so sure? Because I have seen minimum to 10 to 20 to 30 to 40 to 50 to 60 to 90 until 90% of the data I have seen. Definitely this is actually almost 0. But maybe remaining whole 10% is greater than 0. Is this? Am I sure? About the rest of the whole 10% being greater than 0. Am I sure here? Can I say rest whole 10% is greater than 0 without any doubt? Or not sure? I can, at this point, how much of the data I have seen? I have seen until this point, I have seen only 90% of the data. I cannot make a comment on the rest of the 10%. This one is greater than 0. This I am not sure. What is the 100 percentile, which is also known as maximum value? What is the maximum value? 99999. Is it fair to conclude, that means this is the maximum value. Is it fair to conclude that 90% of capital gain is zeros? Remaining whole 10% is greater than 0. Can we conclude this? This is for sure. This is also for sure. Can I surely tell 90% are zeros? Remaining whole 10%. Remaining whole 10% is greater than 0. Can I conclude that? Is it the right conclusion? Or do we need to still look into this 10%? 90% is 0, that is concluded. But what about the last 10%? Have we really looked at that whole 10%? Check that out. Have we really looked at the last 10%? Maybe 95% is 0. Only 5% is greater than 0. That can also happen. Maybe 99% is 0. 1% is greater than 0. The maximum value is 99999. Who knows? Isn't it? Maybe 98% is 0. Only 2% are greater than 0. Any of these possibilities can happen. Yes or no? Think about it. Do you agree with that point? That maybe 99%, maybe 95%, maybe 98% is actually 0. Only 1%, 2%, 3% can also be 0. Or maybe it can be, finally it can be also 90, 10 also can happen, but we cannot be very sure about it. So how do you get to know the information from 90 to 100%? How do you get to know the information from 90 to 100%? I want to clearly know what percent of the data is zeros, what percent of the data is non-zero. That means I need to look at 91 percentile, 92 percentile, 93 percentile. How do I do that? How do I get to know 91, 92, 93, all those percentiles? I look at it here. 91 percentile. How do I get it? 0.91, 0.92 and so on, 0.99. So somewhere there will be more than 0. From there on, I'll be able to catch it that yes, this much of the data is greater than 0. This much of the data is actually 0. So how do I get 91 percentile? 0.9, 0.91, 0.92, 93, 0.93, 0.94, 0.95, 96, 97, 98, 99, 100%. So let me re-import this income data. We need pandas for that. Pandas package, bank data, and then the income data. So initially what we have done, we have looked at the capital gain, standard percentiles, 10, 20, 30, 90. But we don't want to conclude that 10% will be greater than 0. Okay. I want to look at 91, 92, 93, 94 and so on. What I want you to do is don't paste the output for me in the chat window. What I want you to do is analyze that output. Finally, tell me what percent of capital gain is actually 0, what percent? And what percent of the capital gain is greater than 0, what percent? Just give the answer to these two questions. What percent of the capital gain is 0 for sure? Is equal to 0. What percent is not 0? Tell me what are those percentages? What are the answers to these two questions? "91% of the capital gain is 0. 9% is non-zero, roughly. "91 and 9. Maybe it may be sometimes in a different data it could be 95 and 5. In a different data it could be 98 and 8, 98 and 2 also possible. Here it is 91% of the capital gain is 0, 9% is non-zero. Imagine we go to our client with this analysis. We tell our client that we have gone through capital gain and we looked at the complete distribution of the capital gain. What do you mean by distribution? From minimum value till the maximum value. Whatever capital gain takes, we have looked at every value. That is called distribution of a variable. What is distribution of a variable? Within its minimum to maximum limits. What all values it takes, we have analyzed all of them. And we found that 91% of the times capital gain is 0. Only 9% of the times it is around taking positive values, which is greater than 0. Then this is the statistical analysis. This is a statistical inference. The client will bring business knowledge into this, isn't it? The client or the business partner, based on their business sense, they will tell us, they will validate whether our results are correct or not. Imagine I'm your client, I'm giving you this info. Actually, capital gain has to be always 0. That is the right answer. Any negative value, any positive value, negative value which is less than 0, positive value greater than 0. Any of these should be considered as an outlier or erroneous data. It has to be always 0 for everybody. If that is the case, statistical plus business knowledge based on these two, tell me what percent of the data is clean, what percent of the data is outliers here. The percentage of the data that is clean from the capital gain point of view, the percent of the data that is outliers from the capital gain point of view. 91% of the data is clean, 9% of the data is outliers. Always when you are deciding outliers, you have to keep this in mind. Outliers should be decided based on two factors. Factor one is statistical analysis, like the way we have done this percentile distribution and all that. Factor two is business context. The mistake that people do is they just look at the percentile output, statistical analysis, then they tend to decide it. No, always everything should be in the context of business. Let us suppose an age of 85 may be an outlier in a loans portfolio. Maybe a person has 85, then company may not give you a loan. So definitely 85 age may be a very high outlier in a loans portfolio. But if I take savings bank account, in that portfolio, age of 85 is not an outlier. It's very common to have people with age 85 and still having a bank account. So it all depends on the underlying business. We should not just simply look at the statistical result. Always have the business context. Based on that only you should decide what is an outlier, what is not. That is the process of the right way of detection of the outliers. By looking at the whole distribution from minimum to maximum, what all values this variable takes, you have to detect the outliers this way. Detect the outliers by looking at the percentile distribution from minimum to maximum value. If you have understood this, then we will do one more case study. In that one, I will give the problem statement to you. I expect you to find the percentage of outliers. Are you ready? Are there any questions on this that we need to address first before going to the next case study? All right. The next one, the data set that we are using here is a credit risk score calculation, credit risk score calculation, or credit risk score model. The final objective of this model is to detect what is the risk score. Risk score before giving a loan or before giving a home loan, personal loan. I would like to calculate how much is the risk associated with this person. That is the final objective, but we are not fulfilling that objective here. To build this model, has been a data set that has been considered. Now to calculate the risk score, your financial history will be tracked. How many late payments you have made, how many bank accounts you have, what is your monthly utilization of your credit card limit, how many times you have applied for a credit card. Your complete financial history will be tracked. Based on that, risk score will be given. In that, one of the most important variable is monthly utilization percent. Monthly utilization percent is one of the most important variable. For example, if there are two customers, customer A and B, he has a credit line of 1 lakh. Person B also has a credit line of 1 lakh. Person A, on an average, he is utilizing 95,000, 96,000, 98,000. He is utilizing 95,000 on an average. Monthly utilization percent is 0.95, which is like 95%. Person B is hardly swiping it. Maybe he is utilizing 10,000, 12,000, 10 to 12. Mostly around 12,000 is his utilization. So his utilization percentage is 0.12, which is like 12%. If you are a financial institute, if you are a bank who's going to give a loan, whom do you think is more risky? Is it A, who is credit hungry, utilizing a lot? Is it B, who is utilizing lesser? Who is more risky for you usually in most of the cases? Think about it. Try to participate, everyone. Usually the customer whose utilization is high, the customer who is utilizing a lot of credit limit, these are the guys who are risky. That is why monthly utilization percent, this variable is also tracked. When you log into your CIBIL account, you will get this number also. If that monthly utilization percentage is high, you will have your CIBIL score very, very low, or it may impact negatively your CIBIL score. You have to be careful with your monthly utilization percentage. It is not just credit card utilization. Let us suppose if you are taking a flexi loan. Have you ever heard of a flexi loan? They'll put some amount in your account. You can only withdraw a smaller amount. You pay back. These flexi loans, we think that these are small loans, but the flexi loan amount will be considered as the full loan amount. Your utilization will be high. It will impact your credit score negatively. Before taking such kind of loans and taking a loan on the card and all that, be very careful. When you go to a electronic store, just to check whether you are credit worthy or not, whether you are eligible to get this loan or not. They will simply send one inquiry to the CIBIL. Okay, whether you are credit worthy or not. This person is applying for, let's say, 45,000 loan on a particular electronic item. Is he having a good score or not? That number of inquiries also will impact negatively your credit score. Okay, we don't know about those things. We have to have that financial literacy. Otherwise, your credit score is very important when you are applying for a home loan and all that. At a lower interest you can get if you are less risky. Monthly utilization percent is one of the important variable. I'm giving you the business context because you are going to decide the outliers in this. Tell me, what is the minimum value that we can have monthly utilization percent? Monthly utilization percent, the minimum value that you can think of. What's the least value? If a person is not at all swiping, the minimum value is 0, which is like 0%. 0% is the monthly utilization. The maximum value that we can think of, maximum value. Max value is how much? What is the maximum value possible? 100% of the utilization, which is like 1 is the maximum value. 0 to 1 are the limits. These are the right data. This is the right data or correct limits. Can we have negative monthly utilization less than 0? Is it possible? No, not at all possible. So this is erroneous data, or let me call this as outlier or erroneous data. Can we have more than one as the utilization? Utilization more than one, is it possible? 1 lakh is the credit limit. Can I use 1,50,000, 1,30,000? No. That is also outlier. That is also error. What I want you to do is go through this monthly utilization variable. Analyze that variable. Tell me what percent of the data is clean. That means 0 to 1 limit. What percent of the data is clean? What percent of the data is outliers? Only these two numbers you have to tell me in the output. Is it like 90% clean, 10% outliers? Is it like 80% clean, 20% outliers? Is it like 95 and 5? Is it like that? Go ahead, analyze this output and let me know the answer. Yeah, what percent is clean? What percent is having issues? Everybody try to do the analysis and let me know your final result. Let me also do it. This is the data. Monthly utilization. As usual, we will do the standard percentiles. 0 percentile is 0. That means minimum value is 0. Are there any low side outliers like less than 0? Are there anything? No. This is not there. Nothing is less than 0. Minimum value is 0. 10 percentile clean, 20 clean, 30, 40, 50, 60, 70, 80, 90. Until 90, everything is clean. But 100 percentile is 50,708. What is the maximum that we can expect? 1. 1 is the maximum. Even 1.05 also wrong. But here the maximum value is 50,708. If 1 lakh is the credit limit, somebody has filed for 507 crores. Is it possible? You have a credit card with 1 lakh credit limit and you purchased an item which is worth like 5,507 crores. Will the system allow it? System won't even allow 1 rupee more than whatever is a credit limit, isn't it? Unless until you make a special request. Here 507 crores is almost impossible. So is it fair to conclude that 90% is clean? 10% is outliers? Because for me I can see 90% is clean, 10% is outlier. Can we conclude like that? Is it fair to say the whole 10% is having the issues? Now, what should we do here? We should do a drill down. How do I do it? 0.9, 0.91, 0.92, 0.93, 0.94, 0.95, 0.96, 97, 98, 99, 100%. 90% fine, 91 fine, 92, 93, 94, 95, 96, 97% of the data is fine. Is it possible 1 lakh is a credit limit, 1 lakh 6,000? Is it possible to swipe for 1 lakh 6,000? Nope, not possible. So last 3%, 97% clean, 97% clean, 3% is having, you name it as errors or outliers or non-possible values or anything, that is the issue. 3% is the outliers. That is how you detect the outliers. For detection of the outliers, there are two factors that you need to consider. Tell me once again, quick recap. What are the two factors that you need to consider for detection of the outliers? One is the statistical analysis or the percentiles output. That is the first factor. What is the second factor? Important one. Business context. Always business context. The reason why I'm stressing upon it is a lot of people are ignoring this business context. You should be a business analyst first, then only you can become a data analyst or a data scientist. Without the proper business context, our analysis are bound to go wrong. Okay. That is how you detect outliers. Any questions on detection? Will you be able to take any variable in future and detect what percent of the data is outlier? Yes. Any questions on this, anybody? Any questions? Now that you have detected, what is the next step? Can I clean the data? Let us suppose 97% of the data is clean, 3% of the data is having issues. Simply delete this data, work with the 97% of the data. That seems like a simple solution. But we should not do that. You know why? We should never simply ignore this data because we have a large data set. Look at this. We have a large data set. In this data set, one of the column is your column. Apparently, this is utilization column right now, monthly utilization. 97% of the data is clean. In between, around 3% of the data has issues. 97% is clean. If you delete, you will not be deleting only this one column. You will be deleting the information in the other columns as well. The rows need to be deleted. So maybe the other columns that you have, income, number of loans, age, number of dependents, number of late payments, maybe you have that data populated perfectly there. Why do you want to lose this information? We will be buying this data from bureaus. Why do you want to pay to bureaus, get the data and delete it unnecessarily? So deleting is not a good option. Point one. Point two is, okay, you have deleted this 3% of the data. What if in the income there is another place where another 4% of the data has issues? Would you delete that as well? Where utilization is perfect, but you will be deleting this as well. So that's not a good idea. Deleting is not a good idea. But can I keep it as it is? 1 is the maximum value, but the number that I got is 50,000 something. Does that mean can I keep these outliers as it is in the data? Is it going to create any harm or these are harmless? Outliers in general, are they harmless or are they going to impact your analysis hugely? Is it okay to have outliers in your data? Is it fine if we have outlier in our data? Are they harmless? Or is there a chance that they can turn your analysis upside down? What do you think? Yeah, they will impact, isn't it? They will impact. Imagine you have, so we have to somehow clean this data. We cannot keep, we cannot delete. We have to clean it. Let us see how to clean it. For example, this is your data. Rest of the data is available. Maybe at this particular point, maybe sometimes it is missing value. Sometimes it is outlier, maybe this is totally 999 or something, outlier. Sometimes it is some default value, some like something default value is 1111, something like that. So largely, let us call this as the place where you have issues. But remaining more than 90% of the data is clean. This whole data is clean. This is the data that is having issues. Now I have to replace it. What can be the best substitution here? I had to put some number there. I cannot leave it as it is. I had to put some number. What is the most harmless substitution that will not turn my analysis upside down? Is 0 a good substitution always in all the data sets? Is 0 is always a good substitution. Definitely if something is missing, it must be 0 only. Is that a good guess? Let's say this is income variable. If income is missing for someone, definitely he would be earning $0 only. Is that a right idea to think? Think about it. If somebody did not declare income to me, but I know all his neighbors' income, can I think that he was not earning? That's why can we put 0 there always? Is 0 a good idea? What can be the best substitution? Tell me. Yeah. What could be the best substitution? Which is harmless, which is kind of smart. What do you think would be the best one? Either mean or median? Or to be on the safe side, median seems to be a good bet, isn't it? Either mean or median. If I know every other value, if there is something here, by taking the average of the rest of the values, I can always fill this value. Makes sense, isn't it? Or is it going to turn your analysis upside down just by replacing this value with mean or median? Are you going to change your analysis, turn your analysis totally upside down? Or it's going to be harmless? Think about it. Are you keeping the authenticity of the data? Surely we will be able to keep the authenticity of the data. So replacing it with median is the best possible substitution that we can make. It is known as imputation, which is a common practice that has been followed. In fact, this is one of the example that is straight away coming from the credit risk industry only. And we used to work for Citibank. These kind of imputations, we have ready-made codes for them which will actually search for these kind of things, do the imputation in the data. So in our example, 97% of the data is clean. 3% of the data is having issues. What I'm going to do? Wipe out this 3%, replace the 3% of the data with what? What am I going to replace those 3% of the rows, 3% of the places? I'm going to replace it with median, 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 median. That's what I'm going to do. This is known as imputation, missing value or outlier imputation. Here is the process. I have the column called monthly utilization. So my data set name is loans data. In the loans data, I have monthly utilization. Monthly utilization. First, find the median of this monthly utilization. Store it in median utilization. The next step, look at this. Next step is usually we don't override the existing variable. This is the variable that has issues. Keep it as it is. Create a new column. The new column may be loans. My utilization new is a new column equal to loans monthly utilization. Loans monthly utilization. What does this do? It will take whatever is there in monthly utilization, it will store it in the new column. Now we will be cleaning this new column so that we have cleaned version as well as old version of the same column, and we will be using this util new for the future analysis. Here is how you clean it. Loans, util new. Here is the important step, all of you focus. Within util new, I want to focus on only those points where utilization is What are the points that we need to clean? Wherever this monthly utilization is greater than 1. So I have to filter them all out. So here is how you create a filter. Again, write loans, util new, utilization new, util underscore new, wherever it is greater than 1. So what this particular line of code is going to do is it will go to utilization new column. Whenever utilization is greater than 1, it will access all those points. And whatever you write here, it is going to replace all those points. So first we will access all these points. And what are we going to keep in all those places? Tell me, whenever utilization is greater than 1. What are we going to replace at all those places? What should I write here in this code? What should I write here? Median utilization, which was calculated there. The key important point where we are actually cleaning is this step. We are accessing only the points where utilization is greater than 1. Rest of them we are leaving it as it is, replacing them with median util. So if you go to the code part of it, first calculate median utilization. In the second step, create a copy of monthly utilization. In that one, whenever utilization is greater than 1, replace it with median utilization, which means it will give you a warning. Don't worry about this warning. It is trying to tell us we are updating a slice of the information only. Yes, we are intentionally doing it. Ignore this warning. It will work. Now if you see the new variable, which is util new, min value is 0, max value is 1. This is the cleaned version. Original version of the variable which is uncleaned is monthly utilization. Min value is 0, max value is 50,000. Util underscore new will be the variable that will be used in all the further analysis from here on. As a general standard, as a good standard, we generally, when we are working on projects, we don't overwrite the variables. We have to keep track of all the previous historical changes in a variable. That's why we don't overwrite a variable as it is. We'll be creating a new variable while cleaning. Go ahead, do this cleaning process. Done with this? Once again, the important piece of code is here, where from utilization, you're taking only those places you're accessing where utilization is greater than 1, replacing them with median utilization. This is part of data cleaning. Data cleaning requires a lot of patience. We need to explore the data. For data exploring, you look at mean, median, percentile distribution and all that. You validate the data based on the business logic. You find out what are the acceptable limits, what are the outlier definitions and all that. Then you clean the data. This whole process requires more patience than the technique because there can be several columns. We have to go through all those columns. All right. That concludes our first session. The first session is basically more of a discussion on basic Python commands, some of the basic descriptive statistics, which will be kind of foundations or fundamentals, which are very much required. One should know what is mean, what is median. Without these, it will be very difficult to proceed further. One should know how to do the basic exploration using percentiles. How do you detect outliers? How do you do the imputation and all that? These are kind of very basic skills one we should have. Then only we can get into the machine learning algorithms and all that. So that is our session 1, where we have discussed some of the basic fundamental concepts. We will be getting into machine learning algorithms in the upcoming session. But before getting there, we will take a lunch break. Before the lunch break, I would like to take the questions from you. Anybody, if anyone has any questions, you can go ahead and ask me. All right, then if there are no more questions, we will take a lunch break. Let's meet at 1:50 p.m. Exciting topics have been lined up. We'll get into the machine learning algorithms right after the lunch break. Fine? All right, then. Let's meet at 1:50. Thank you. Welcome back, everyone. Once you are back at your desk, send me a message. Once you have reached your desk, send me a message. Let's wait for others to confirm. Let's give a couple of minutes. Let's give one more minute for others to join in. Okay. Whatever we discussed until now is known as univariate analysis. Univariate analysis. Univariate means you take one variable x, you find its mean, median, standard deviation, variance, you detect the outliers, you clean the variable. Only one variable was in focus, in isolation. We will now slowly move on to bivariate analysis. Bivariate means two variables, x versus y. Are they positively related, negatively related? As x increases, what happens to y? Are they related at all or not? That is bivariate analysis. Studying the relationship between two variables. Later on, we will slowly move on to multivariate analysis. What is multivariate analysis? x1, x2, and so on, xk using k variables. Can I predict the target variable y? Out of these k variables, what are the most impactful factors on y? What are the drivers of y? That will be the multivariate analysis. We have completed univariate analysis. Let us go to bivariate analysis. What do you think? Is there any association between the hours of study and the final marks that we get? Is there any association between these two? Or they are not associated at all? What do you think? Some people will say yes, there is association. Some people may not agree to that 100%. Is there any association between temperature and sweater sales? What about this one? Temperature and sweater sales, are they associated? Yeah. This one there must be no doubt here. Looks like definitely they are associated. As the temperature increases, when it gets hotter and hotter, what happens to sweater sales? They will go down because it's getting hotter. As the temperature decreases, as it gets colder and colder, the sweater sales goes up. Definitely if I take temperature X, sweater sales Y, these two must be associated. Most often they will be. What about the association between temperature and ice cream sales? Temperature same X versus ice cream sales, let's say Z. Do you think those two will be associated, or we cannot really guess confidently? Whenever we have these questions, you know what you need to do? You need to look at the data, let the data tell us whether they are associated or not. Even this one, hours of study and the marks, take the data of, let's say, 1000 students. Let X be the variable which is hours of study. Let's say how many hours every week, the numbers of hours of study. Student, how much time he has spent on studying. That is the first variable, X. Second variable is wait for 3 months. You will get the marks. This is Y variable. X versus Y, you try to find the association. 1000 students, hours of study. 1000 students, their marks are in front of you. Is there any statistical measure that will tell me how strongly, how weakly these two variables are associated? Given any two numerical variables, if you want to know how strong, how weak they are associated, you can use a measure called correlation coefficient. Correlation between X and Y can be calculated. Correlation coefficient is the value that will tell whether two variables are associated or not. This is the statistical measure. The formula for it is, in the denominator you have under root variance of X into variance of Y. That will be like, we already know what is variance of X, summation xi minus x bar whole square divided by n, into variance of Y, summation yi minus y bar whole square divided by n. In the numerator, you have covariance of xy. It is known as together variance. Summation xi minus x bar into yi minus y bar divided by n. Covariance of xy divided by square root of variance of x into variance of y is the correlation coefficient. This is individual variance in x. That means within x, how much it is changing from its mean. Within y, how much it is changing from its mean. Now this is together variance between x, y. Whenever x is moving from its mean, is y is also moving a lot from its mean. Whenever x is far away from its mean, is y at all changing from its mean, or it's almost same? Whatever x is doing, if y is not at all reacting to that, then covariance will be very less. In the numerator, you have together variance divided by individual variances. What this will do is, given two numerical variables, it will tell us whether they are associated or not. You find this correlation coefficient. If that is 0 to 0.25, you say negligible association. 0.25 to 0.5, weak association. 0.5 to 0.75, moderate association. 0.75 to 1, strong positive association. 0 means no association. Near to 1 means very strong positive association. Between two variables x and y, can there be only positive association, or can this be taking negative values? Is it possible that as x variable is increasing, can it be possible that y is related but inversely related? As x increases, its related variable y is decreasing. Is it possible in real world scenarios? Can you give me an example as one variable is increasing, the other variable is related but it is decreasing? The same example, our temperature versus sweater sales.
I mean, voltage and ampere amps.
So, yeah. So, yes, it is possible that variables can be inversely proportional, demand and supply, all those things. As x is increasing,
Even the
y,
gravitational rule is also there.
x versus y, if you see here, as one variable is increasing, it is possible that the other variable is decreasing. In fact, the example that all of us have agreed, as the temperature increases, sweater sales go down. It is possible that the correlation can be negative. Same way, 0 to minus 2.5, 0.25 minus 0.25 is negligible. Minus 0.25 to minus 0.5 is weak, negative. Minus 0.5 to minus 0.75 is moderate, negative. Minus 0.75 to minus 1 is strong, negative. That is how you can quantify the association between any given two variables. If I take two variables x, y, the correlation value that I found between them is plus 0.2. If I take another two variables x comma z, Imagine the correlation between these two variables is minus 0.8. Which correlation is higher? Which one of them? XY correlation higher or XZ correlation is higher? Just that there is a positive sign, it doesn't necessarily mean this is always higher than this. XY correlation is 0.2, which means it is a, what is it? How do we convert it? If its correlation value is 0.2, how do you infer it? You are going to say this is a negligible positive association versus, what about this one, minus 0.8? Negligible positive association between XY versus, what does minus 0.8 mean? Strong negative association. Strong negative versus negligible positive. That means X and Y are not as much related as X and Z are. So the sign depends on the type of the variable, nature of the variable. Always we should not pay or give a lot of importance to sign. Okay. The sign depends on the nature of the variables, but the quantity, the number matters. The number will tell us whether these two variables are associated or not. That is the theory of correlation. What we will do is, as usual, we'll take a case study. We will take the data and see where it can be used, or in Python, if we are writing any code for correlation, what will be the output, how to interpret the output, etc., is what we are going to discuss. Let us take a case study. There is a data set that we are going to use. This has been shared by one airline company. I'll explain you their business problem. Then we will try to solve that particular problem using the measures that we have discussed. So here is the business problem. Listen to me carefully. This airline company, they have gathered 80 weeks data. 80 weeks, nearly 1.5 years, 1 year, 8 months or something. 80 weeks data is what they have gathered. Now week on week, they have gathered these details. The number of passengers, week number is the first variable. The number of passengers, promotional budget that has been spent. The idea, this airline company, you know what they want to do? The number of passengers is the critical key variable for them, passengers. They want to find out what are the main drivers on these passengers. What are the key factors that are influencing the number of passengers? There are some factors under their radar. They will be testing those. So what they want us to do is take this data, do the analysis for me, tell me what are the most influencing factors on the passengers for me. So my passengers is my target for me. This is the most critical variable. Usually target is given by the business partner itself. Well, imagine I am your business partner. I am telling you my target is analyzing the passengers, and I want to find what are the major key influencing factors from the list that I have given. Usually target is denoted by Y in general. Promotional budget. Promotional budget is the amount of money that is spent on giving offers, coupons, some kind of reduction in the ticket fare, amount of money spent on marketing, etc., etc. In general, do you think promotional budget has anything to do with number of passengers? As promotional budget increase or decrease, do you think passengers will be impacted or no impact in general sense, normal intuition wise? We know a little bit of airline industry. We know that if there is a reduction in the ticket fare, usually passengers may increase. Usually it should have an impact. However, we have to look at the statistical measures. We have to look at the data and decide whether our intuition is correct or not. Promotional budget, service quality score versus passengers. Holiday versus no holiday. Does it have any impact on passengers? Delayed or cancelled flights. Does it have any impact on passengers? Inter-metro flight ratio. There are flights between metro cities. There are flights between non-metro cities. Do you think does that number really matter? If I have more flights between metro cities, is it going to increase my passengers, or is it the other way around? If I have flights between non-metro cities, people find the only one option, only I will be the one. Is it going to impact the passengers? Bad weather versus good weather, does it have any impact? Technical issues, Does it have any impact? Like that, these are the variables that are under our radar, and we want to know whether they are really truly influencing the number of passengers or not. That's the first question. So the first question that I have is promotional budget. Is it related to passengers or not? Based on the data, if you have to answer that question, which measure are you going to use? Promotional budget and passengers, are they related or not is my question. How do you answer that question? How can we answer it? Tell me, what is the measure? Two variables, are they related or not? We are going to calculate the correlation,
Correlation. Yeah.
correlation coefficient, isn't it? So I'll take the promotional budget, passengers, and promotional budget. Passengers and promotional budget, I can find the correlation coefficient. Usually, when you are taking two variables, let's say first variable is passengers.
So I mean, extrapolating, we'll be going to regression, right? Linear regression.
We'll do it later. Like we'll
Okay.
focus on whatever is the discussion. So you
Okay.
told the climax anyway. So
Sure.
yeah. I'm taking like a story. So there is some suspense and all that in this.
I
Okay.
understand.
Yeah.
Sorry. Please continue.
Yeah. Okay. Huh. So I have two variables, passengers and promotional budget. What I want to do is I want to find out whether there is any relationship between them or not. Usually when you are giving two variables, X and Y, the output that you get will be a matrix. It is known as correlation matrix. So in the output, you will get again passengers and then the promotional budget. Okay. So this number over here in this cell will be the correlation between passengers and passengers. If I take a variable and with its own, if I find the correlation, how much will you get?
1.
1, isn't it? If I take one variable with its own, it will be fully correlated. Will it be 1 or 0? Think about it. If I take one variable x with its own x and x,
1 only.
Yeah, every variable with its own, it will be completely related, isn't it? 1. What will be this number over here? It's a correlation between promotional budget and promotional budget. How much that
Again
would
1.
be? That will be 1. The number over here is a correlation between passengers and promotional budget, which we are going to find now. This number over here is a correlation between promotional budget and passengers, which will be same as this one. Correlation between XY will be same as correlation between YX. Even if you go to the formula, nothing changes. Okay. Go ahead, create this correlation matrix. First of all, we need to go to our Google Classroom, close today's morning's file, go to classwork. Linear regression will be the folder, regression analysis. So this is the code file that you have to reach. I'm pasting the same link in the chat window. Either you can reach using the classroom path that I told you, or you can directly click on the link that I gave you. You will be here. I want you to import the data, run anyway. Import the data and then calculate the correlation. Only until here you have to execute. Only until whatever we're discussing, execute that code snippet and let me know the correlation value between passengers and promotional budget. So what is the correlation value? If somebody asks us what is the correlation value between promotional budget and passengers, are we going to give 4 numbers? Nope. What is the correlation value between passengers and promotional budget? The correlation value is 0.0 9658. But I don't understand all these numbers. I'm a layman. I don't know how to interpret this. What does this mean for a layman? What are we going to say?
It's highly related.
These are, what is that? Strong. There is a strong
relation.
positive association between promotional budget, as we expected, promotional budget versus passengers. There is a strong positive association. Why there is a strong positive association? Is it a random statement that we are making, or is there a reason for it? Correlation value is 0.9658. Beyond which point you would say there is a strong positive association? Tell me your benchmark. When do we say there is a strong positive association? When the correlation is above 0.75, we'll say there is a strong positive association. Okay. The same number will be here also. Imagine we are going to our client and presenting this basic kind of data that we have seen. Let us suppose this is our first meeting. We told that we found the correlation between promotional budget. We did some analysis. We first cleaned the data, and all the data cleaning and all that, that will be as usual. I'm giving you the cleaned data, but in reality what happens? We have to get the data, we have to look at each variable by variable. That process is non-avoidable. We will always go through that step. After that, when we are analyzing, when we are exploring, when we started finding the relations between two variables, when we came to bivariate analysis, I started looking at the relationship between passengers and promotional budget, and we got 0.96, which is an indication that there is a strong positive association between these two variables.
Thank you. How we will come to conclusion that this after 0.75? Can you repeat that? I didn't get.
So the correlation minimum value is -1. Okay. Maximum value is +1. So if we come to here, this formula that you see here.
Yeah.
So this, it takes the maximum value of +1. Okay.
Okay.
Which means if you give one variable x with its own variable, if you take, that is the maximum correlation you can have. There's absolutely no difference between two variables. Then you will get +1. The minimum value is -1.
Okay.
For correlation, when there is a absolutely negative correlation. The middle value is 0. So the limits are given like this: 0 to 0.25, it is negligible correlation. That means if you get a correlation of 0.1, you will get a value definitely in the mathematical measure. It's almost negligible. That means hardly whenever x is moving, hardly you will see any movement in y. Okay.
Okay. Okay. I got it.
So like this 0.25 to 0.5. From here we decided that anything above 0.75 is a very strong positive association. Okay.
Yeah. Thanks.
Now, imagine that we are presenting this to our business partner. We told him that promotional budget and passengers are very strongly associated. The client will ask you, how can you say that so confidently? Then we'll tell him that we used a statistical measure called correlation coefficient, which is giving to be somewhat around 0.9 or above. It seems it's a strong positive association from the data we got to know. Then the client will validate your results based on the business knowledge that he has. Yes, whatever you told me is correct. That's what my client told me. The client is telling you, whatever you told, promotional budget and passengers are related. That is correct. Your analysis is right. In fact, even in my experience, I have seen that whenever we started giving more and more promotions during Thanksgiving, during Christmas, we have seen the passengers have increased. Even in between also, whenever we give more offers, we have seen a lot of passengers. There is a slight increment in the passengers. But you know what? This I already knew. Since anyway you're doing this analysis, if let's say next week we are planning to spend around $500,000 on promotional budget. Next week, our plan is to spend $5 lakh, $500,000 on promotional budget. Can you predict the number of passengers? That's what the client is asking you. The client asked us, Since you are saying these two are very much strong, positively associated, if I am planning to spend 500,000, $500,000 on promotional budget, can you predict? Predict is the important word here. Can you predict the number of passengers for me? By the way, is that a fair question?
We can predict the range, but then we have also have to maintain the, I mean, mention the confidence level that we'll have in that particular estimate.
Right. So first of all, is this a fair question to ask?
Fair enough. Yeah.
Yeah, isn't it? In fact, these are the kind of questions that we also need to be prepared, isn't it? Because most of the cases, the clients may not know statistical analysis and all that, but the questions that they ask are very much related, very much fair. So the question is, if I'm planning to spend this much amount, can you tell me how many passengers are going to come? This is the question. Looks like a fair question. Unfortunately, correlation coefficient that we have seen, this cannot predict. Correlation coefficient is a very simple measure. The formula is very simple. Given two variables x and y, whether they are positively related or negatively related, whether they are strongly associated, weakly associated, that correlation coefficient can tell you. But what it cannot do is it cannot predict. Correlation coefficient formula doesn't have the ability to predict the target variable y given at any value of x. Correlation coefficient doesn't have the ability to predict the corresponding value of y. This cannot do. No way. No matter what tweaking we do. Is there any other measure? Yes, definitely there is one more measure that will try to help us in predicting. Let us see what are the options. First of all, correlation cannot be used for prediction. Let's see what's there. Imagine this is the data between x and y. This is the relationship. When you draw a scatter plot, here is a variable x, here is variable y. This is how the scatter plot looks like. Looking at the scatter plot, can you conclude anything? X and y, are they related to each other? Or they are independent of each other, not at all related? What can you say by looking at the scatter plot? Looking at the scatter plot, sometimes we
The
can
sum
get
of
an idea.
variance would be very low, so these two variables are strongly correlated. Or
Looks
associated.
like they're very much associated, isn't it? Because if you see the value of x, when x is very small, y is small. When x is very large, almost when x is in the range of 45, 55 and all that, y is also very large. Looks like as x is increasing, y is also increasing. Looks like these two are very much highly correlated. In these kind of variables, if you have this system like this, when you find the correlation here also, you may get very high correlation. Very high correlation, maybe more than 90% or something. Now let me ask you another question. If the value of x is 30, can you tell me the predicted value of y? What is the predicted value of y? Maybe at least the rough value. Roughly around which value the y will be here. Look at this. When the value of x is 30, roughly what is the predicted value of y? Roughly around 40. Makes sense. Look at that, all of you. Do you agree with that? Looks like a lot of people are already giving that answer. The predicted value of y would be somewhat near to 40, isn't it? Most of the people are saying the predicted value of y is 40. Now let us take one step back and think, how did we come to know 40 is the predicted? 40 is correct answer, agreed. But how did we come to know 40 is the number? How did you arrive? Most of the people have done it. How did you arrive at it? If we take one step back and check what did we do? You have imagined a line through this data. Yes or no? You have imagined a line through this data. What we will do in this course is we will not try to use the word that we haven't discussed until now, isn't it? We will try to only when there is when a new term is introduced, then only we'll try to use that, isn't it? So you have
So we will
imagined.
not use mean square error here.
So we have imagined a line here. Yes or no? I'm just talking about the normal intuition.
Okay.
Nothing very statistical, nothing very complicated, very simple. Like I asked you a question, when x is 30, tell me what is your y. That's what I asked you. I did not ask you to use any of the statistical technique or machine learning or mathematics or anything. Simple question. I have shown you a graph. Yes or no? And I asked you, if x is 30, what is the value of y? At least roughly predicted value of y. That's the question that I asked. And how did you come to know that? You did not use any least squares or anything. You simply imagined a line through this data. Yes or no? People who have told me that the value of the y, predicted value y is 40. How did you come to know? You have imagined a line through this data. Yes. After that, when I said x value is 30, you have imagined another line, a dotted line or something, whatever is the line. It is hitting the point here. And then you started drawing this, then this is 40. That's how you came to know this is the 40. There are so many lines in this plane. There are so many lines. But why did you choose only this line? This is the line that goes through our data. Yes or no? The line must go through our data. This is the line that represents the relationship between x and y. The relation between x and y is captured in this line. This is the line, most importantly, it gives me the predicted value of y. Predicted value of y at any given value of x, not just at 30. Even if I would have told you at 20, you would have given me the prediction. At 20, you would have given me the prediction. At 40, you would have given. At any given value of x, you would have given me the predicted value of y. So there are so many lines. Out of those lines, you have considered that line that goes through your data that represents the relationship between x and y, that gives you the predicted value of y at any given value of x. The prediction is the one this line is making. The line that you have imagined that gives you this value of y is known as regression line. This line is known as regression line. That is the definition of regression line. So if you ask me statistically, what is the definition of regression line? This is the definition. The line that goes through most of the points in the data. The line that captures the relationship between x and y. The line that gives us the predicted value of y at any given value of x is known as regression line. Knowingly, unknowingly, we all know about the concept of regression already. The thing is, formal, exact formula and the technique is what we are going to discuss in the session. This is just the intuition behind the regression line. What is the main use of regression line? It gives you the predicted value of y at any given value of x. That is known as regression line. However, in English, general English, I can say line and all that. But in statistics or in mathematics, a line has an equation. If I say a straight line, you have to write the straight line equation. Then only I will be calling that as line. Can you tell me the straight line equation? In mathematics, what is the straight line equation? In a maths class, if somebody asks you, write the straight line equation, what do you write? What is the thing that we know? Y equal to, do you remember it? Y equal to mx plus c is the straight line equation. Do you remember it? Somewhere we might have
Yeah,
seen
we
it,
need
right?
the gradient to find
Yeah,
the equation. Yes.
right? Y equal to mx plus c is the line equation. This is the regression equation. The regression line equation is y equal to mx plus c. In this c is known as intercept. In this equation, m is known as either slope or coefficient of x. Y equal to mx plus c is the regression line equation. Do you have the values of x? Yes, I do. Do you have the historical values of y? Yes, I do. Based on historical values of x and y only, I could draw this graph. For drawing this graph, I required x and y values. Yes, I have the values of x and y. Based on that data of x and y, we need to find m and c. Then we are through. Then the line is found. If you change the value of m, if they change the value of c, then the line will change. Let's say this is y equal to 2x plus 0.5. This is this line. This line is y equal to 3x plus 0.8. This is another line, y equal to 3.5x into 0.9. This is another line. When you change m and c values, the line changes. Based on the values of x and y, we need to find the best optimal regression line. That means best values of m and c. Once we find those, then we are through with the regression line. We have to find the best one because there are so many lines possible, isn't it? Obviously, infinitely many number of lines are there. We have to find the best values of m and c so that our data goes through that particular line. Most of the points, if not all the points. This is a straight line equation, but that is a kind of elementary equation. The equation is written in Greek language usually. The same equation is rewritten in regression. The actual regression equation need to be rewritten. Y equal to mx plus c has been rewritten as y equal to beta naught plus beta 1 x. Okay. This is the regression line equation. In the place of c, what did we write? In place of c, we wrote beta naught, which is known as intercept. In the place of m, what did we write? We wrote beta 1, which is known as coefficient of x. If you have, let's say, 5x, 5 is known as coefficient of x. Similarly, beta naught plus beta 1 x is the regression line equation. Remember, not always a straight line will fit to your data. Sometimes a curvy line. Straight line means linear line. Sometimes you may require non-linear. We are going to see non-linear lines later on. As of now, the data that we have looks like a straight line fits perfectly. We are going to build a straight line or a linear regression line. This is the regression line equation, y equal to beta naught plus beta 1 x. What is the use of it? It will give you the predicted value. The straight line equation is y equal to mx plus c. Regression line equation is y equal to beta naught plus beta 1 x. Next time when you see this, will you be able to identify this as regression line equation? A regression line equation, nothing but a straight line equation, y equal to beta naught plus beta 1 x. According to your case study, the airline industry that you're talking about, can you take a moment and tell me what is your x variable in our case study? What is your y variable? Go ahead. Tell me in the chat window what is your x variable. Write down the x variable. Write down the y variable in our case study according to our case study. Write them down in the chat window, everyone. What is that x that we are using for prediction? What is that y, which is our target, which we are actually trying to predict in our case study? In our case study, x is what? Promotional budget. Looks like all of you got it correctly. It depends on the case study. I cannot always say first variable is x variable, second variable is y variable, nothing like that. Underlying business case, our business case is predicting the passengers, isn't it? Using the promotional budget. For us, x variable is promotional budget, y variable is passengers. That means to build this model, to build this regression line, you need to have the historical data of promotional budget. Do you have the historical data of promotional budget with you? Right now, do you have the historical data of promotional budget with you? Do you have it? Yes. Around 80 weeks data we have. Corresponding number of passengers data. Do you have it? Do you have the passengers data as well? Think about it. Do we have the historical data of promotional budget? Yes, we do. Do you have the historical data of passengers? Yes, we do. Given the historical data of promotional budget, given the historical data of passengers, building a regression line means finding the value of beta naught, which is intercept, finding the value of beta 1, which is known as coefficient of x. Once we find these values, that is nothing but regression model building. That regression is done. That means the only problem that we need to solve is how do you find these values? Using which technique I can find these values is the question. So how do you find these values? Here is the process of finding the values of beta naught and beta 1. Usually you can imagine when you give the data of x and y to Python, it will find the values of beta naught and beta 1 automatically and give you the result. But what process it follows in the background, if we have to look into that theory, here is what it follows. How those beta naught, beta 1 are estimated using this process. Look at this. Imagine these blue dots are your data points. These are my data points. Imagine this green line is your regression line. As of now, I don't know the exact regression line. I'm writing the abstract form y equal to beta naught plus beta 1 x. This is the line. If I take this particular point here, at this particular point xi, what is the predicted value of y? Is it point A? Is it point B? Or is it point C? At point xi, what is the predicted value of y? Prediction means prediction made by the regression. Is it point A or point B or point C? At this point xi, regression is predicting this value to be point A. This is the value of y. But if I look at the data originally, at this same point xi, what is the actual value of y? Actual value, real value of y. At xi, what is the actual value of y? Model is predicting it to be, regression line is predicting it to be point A. But what is the original value of y? Is it the original value of y? Look at the data. At this point xi, the actual value of y, this is xy point, xi point. Actual value of y is c, isn't it? Is it fair to say, if I choose this model finally, this will be the error made by this line at this point? Is it fair to say, actual value is here, predicted is here, this much as the error has been made by the line at this point? Similarly, error over this point, error here, error here, error here, error here. These are all the errors made by the line at all the points. At this point, this much error. At every point, it is making some error. There are some positive errors. Sometimes the predicted value is lower. There are some negative errors. Sometimes the predicted value is higher. Original value is here, predicted value is here. Tell me, if this is a good regression line, what should be these errors overall for a good regression line? At the end of the day, all these errors have to be, it has to be as minimum as possible, isn't it? This is one line that also has errors. This is another line that also has errors. This is another line. If you have to choose that line that has the least amount of this error, there are so many lines, but out of all these lines, which line has the least amount of error? That is what we have to choose. So that means we have to minimize sum of errors. However, minimizing the summation of the errors has some small twist. Few errors are positive, few errors are negative. That is why instead of minimizing sum of errors, what should I minimize? Minimize sum of, remember this trick that we did?
square.
Sum of squares of errors. So find such line that minimizes the sum of squares of errors. That is the final optimization function. What is our optimization function? Minimize sum of squares of errors. What is an error? Minimize y actual minus y predicted whole square, that need to be minimized. Minimize y actual minus y predicted. What is y predicted? Beta naught plus beta 1 x. This need to be minimized. We have now converted this into an optimization problem. Find such beta naught beta 1 that will minimize sum of squares of errors. Using this minimization optimization technique, we are going to find the beta naught beta 1. In simple words, We will try a certain beta naught, certain beta 1. Let's say beta naught is 2.5, beta
Are you able to hear him? Anybody?
I think there could be some audio issue.
No.
Hello, can you hear me? Hello?
Yeah, we can hear
Yeah,
you. Yeah.
sorry, there was a small glitch from my side. So what we're going to do is, we'll try different values of beta naught and beta 1. Let's say beta naught is 2.5, beta 1 is let's say 0.5. That gives us an error of let's say 100. Then we try a different value of beta naught, different value of beta 1. That gives us an error of let's say 80. So out of those two, the second option is better. Similar to that, we keep on trying different values of beta naught, different values of beta 1, and choose the best possible outcome. What is the best possible outcome? That pair of beta naught, beta 1, which gives us the least or the minimum error. This whole process of finding the beta naught, beta 1 is known as OLS technique, ordinary least squares technique. Using ordinary least squares technique, Python or this regression is going to find beta naught, beta 1 values and give us the final output. In reality, do we need to write the code for doing this ordinary least squares technique? Not required. All that we need to do is give the data. Give the data x and y to x comma y data need to be given to Python. Automatically Python will do this OLS, ordinary least squares, find the value of beta naught, find the value of beta 1, give it to you in the output. So this whole process is known as regression model building. That equation, once you have the beta naught, beta 1, that equation is found. That equation is also known as the model. That is the process of building the regression model. If we come back to our case study, so in our case study, we are supposed to give what is y variable, what is x variable to Python. Here is the code and the syntax. First import the package, SM. There is one more package that I'll introduce to you later. As of now, stats models is the package that we are using. Tell what is y variable, what is x variable. So here we write in the formula y tilde x. Always the formula should be y tilde x. So here is the syntax sm.ols. ols stands for ordinary least squares. OLS function formula equal to. Until here it is syntax. Okay. Y tilde x. Tell Python what is your y variable. My y variable is passengers. Tell Python what is your x variable. My x variable is promotional budget. Tell Python where can you find these two variables. You can find these two variables in a data set called air. Whatever is the data, sales or whatever is the name of the data. Model, this is model configuration. In the configuration step, you tell what is y variable, what is x variable, what is your data set name, etc. Then you say model.fit. When you say .fit, the OLS will take place. Different values of beta naught, different values of beta 1 will be tried. The best combination of beta naught, beta 1 will be given to you in the output. Once you say this, by here the model is built, everything, all the results will be stored in fitted one. Once you say fitted one dot summary, apart from beta naught, beta 1, several other metrics are also calculated. So the summary, it will give you the output summary of the model that you have just built. The regression output results it will give in a large summary. We will talk about all of them, all these measures we will talk, okay? But right now we have talked about only two of them. One is beta naught, which is known as intercept. So you will not see beta naught in the output, you will see intercept. Beta 1, which is known as coefficient of x, whatever is your x variable. For me, x is promotional budget. Both of them together are listed under regression coefficients. These are known as regression coefficients. Okay. Go to this particular part of the code snippet. I haven't completely explained you this summary, but I still want you to execute this model, go through the summary, see whether you can find beta naught, beta 1 values. Fetch those beta naught, beta 1 values by going through the summary output. Go through the summary output, fetch the values of beta naught and beta 1. There are other measures that you will find in the summary output. We will go through all of them. All of them are important. We'll but you have to search for it. Beta naught, intercept value, beta 1, coefficient of x. Tell me both these values. So where are they? Let me also do it. Let's go to here. This is the regression y tilde x. What's the output? For me, I have to re-import disconnected in between. I re-execute it. Beta naught, which is known as intercept, is 1259.60. Beta 1, which is known as coefficient of promotional budget, is 0.0695. Where can I find them? Both of them together are known as regression coefficients. Intercept is 1259.6058. Promotional budget is 0.0695. Apart from this, do you think the rest of the measures in this summary, do you think are they important? Yes, they are important. Are we going to discuss? Yes, we are going to. One by one, we'll discuss all of those. Okay. As of now, we discussed beta naught and beta 1. The remaining are upcoming. Can you write the regression line equation finally? Write the line equation, all of you. In the chat window, give me the line equation. What is the regression line equation? Don't use y and x. Use your case study terminology. Don't use y and x terminology. What is your y? Write down that. What is your x? So finally, after building this model, if I ask you, give me the regression line equation, what will you give me in return? That's what you're going to write there. So the regression line equation will be everybody try to attempt. What is the regression line equation or regression model? This is known as. If I ask you to give me your model, the regression model that you have just built, what are you going to give me? Or in a mail, I asked you as a client, send me your regression model. What are you going to write down? The regression model is nothing but regression equation. So what are you going to write down? What is your final regression model? Passengers equal to beta naught value. What is beta naught, which is also known as intercept? How much have you got as intercept? What is the intercept value? 1259.6058 plus beta 1, which is known as coefficient of promotional budget. How much is that? 0.0695 into promotional budget. This is the regression line equation, the one that you see here. This is the regression line equation. Can you answer the client question now? Previously, the client has asked you a question. Next week, I'm planning to spend $500,000 on promotional budget. Can you predict the number of passengers? Was the question asked by the client. Can you answer his question now? If yes, tell me, what are the predicted number of passengers? Predicted number of passengers. Predicted number of passengers are roughly around 36,000. The reason why it's called a model, why it is called a regression model, it takes the input, this is the input, it gives the predicted value as the output, input to output. That's why it is known as model, regression model. It is also known as predictive, since it gives prediction, predictive model. Believe it or not, it is known as machine learning model. This is our first ML model. What is machine learning? Some people have a misconception about machine learning. They tend to look at this machine learning term and take the literal meaning of it. Machines learning on their own, or some kind of robots doing something. That's what people understand machine learning as. No, that's not the definition. Machine learning means machine understanding the patterns in the data. Machine understanding the patterns in the data. Creating a mathematical equation out of those patterns. Creating a mathematical equation so that we can use that equation for prediction. This whole process is known as machine learning process. Machine understanding the patterns in the data, create a mathematical equation so that we can use that equation for the prediction. That mathematical equation is known as machine learning model equation. Model equation is used for the prediction. This whole process is known as machine learning. Here the pattern is pretty simple. One straight line is sufficient. Later on, the machine learning models that we are going to discuss will be much more complicated. There the applications will be much more advanced. Here it's a very simple machine learning model. Regression is one of the simplest ML model that you can think of. That is the basic equation of machine learning model. Okay. I'll pause here, take the questions. There are so many other things in regression that we are going to discuss. It is just the starting of it. It is going to get a little bit more complex. But whatever we discussed until now, are there any questions on that? All right. Yeah, please go ahead.
In the code, there is, when I'm running the summary,
Yeah.
the covariance type is coming as non-robust, right? What is its implication, please?
So you can ignore that, like this, nothing.
Okay,
Yeah.
okay. Thanks.
Now listen to me carefully, all of you. But actually, I never gone through it. Maybe I'll just go through it and try to tell you like what is the easiest way to understand it later on. Okay. But as of now, from the model building point of view, we can ignore it. Okay. Yeah. but we'll try to know like what exactly that means. I'll come back to you on this. Imagine you are predicting the number of passengers. Why? Using the promotional budget. Look at this carefully. All of you, this is very important. Using promotional budget, we are predicting the number of passengers. What if there is another data scientist who is predicting the number of passengers based on our data set only? But you know what? He is not using promotional budget. He is using, let's say, inter-metro flight ratio, some other variable. By the way, do you have any such variable? Inter-metro flight ratio. If we go to the data, looks like there is a variable called inter-metro flight ratio. The percentage of flights between metro cities, non-metro cities has been used. There is no rule that I have to use only promotional budget for predicting the passengers. I have this column as well. So he has gone ahead with a different hypothesis. So he built a model with inter-metro flight ratio. Using our model, we gave a prediction that around 36,000, is it? 36,000 passengers will arrive next week. That's what we gave, 36,000. But using this model, that person is saying that no, not 36,000. Only 15,000 passengers can be expected next week. This is what the prediction given by, let's say, model M2. This is what the prediction given by model M1. Now I'm in a fix. Which model prediction I should take seriously? Is it model M1 prediction that I should take seriously? Is it model that M2 prediction that I should take seriously? This is also a regression line. This is also a regression line. This also used OLS technique. This also used OLS technique. If I have a regression line, how good is my regression line? How good is my regression line is the first question that we should ask. Until now, whatever we have done is known as model building. Until now, it is known as model building. As a data scientist, model building is only half of your job. Immediately after model building, you should do something called model validation. Then only your job is complete. Right after model building, you have to do model validation, which is like how accurate, how good is my regression line. Because two models, model M1 is predicting passengers using promotional budget. Model M2 is predicting passengers using inter-metro flight ratio. Both of them are predicting the same thing. But if they are predicting the same target, which model I should pick, which model predictions I should take seriously is the question. How do I answer this question? So here is the possible solution. Look at this carefully. Do you have the data set with you? Yes, I do. Do you have the variable x1, which is promotional budget? Do you have it? Yes, I do. Do you have the passengers? Yes. Let us call that as y actual. These are the promotional budget values. These are the passengers values actually. Take model M1. Give the promotional budget as input. Then you will get y predicted values. Predictions are made by M1. How is it possible? Have you done any prediction in your past? Yes. We have supplied 500,000 and we got the predicted value to be 36,000, isn't it? Similar to that, supply all the values of x, you will get all the predicted values of y. Repeat the same process with model 2. Take variable x2. Y actually will be anyway same. Take model M2, supply x2, then you get y predicted values. These are the predictions made by model M1. These are the predictions made by model M2. The results are in front of you. Imagine these are the predictions made by M1. Imagine these are predictions made by M2. I want you to go through these two tables carefully and let me know which model is doing a good job here. Are you going to go ahead with model M1 or are you going to go ahead with model M2? Or we cannot decide anything, that is nothing that is clear. One of these three answers, try to give me. Is it model M1 that's good? Is it model M2 that's good? Or both are one and the same, nothing out of these two is good? Is that the answer?
The model 2 is better. It's good.
Model
Sorry,
2
no,
is
it's
better.
bad. It's bad. Yeah.
Okay.
Model 1 is better. Yeah.
Almost unanimously, everybody is saying model M1 is better. How did you do it? If we take one step back, almost all of us are thinking the same way. What are we thinking? If model is good, whatever is actual value of y, the prediction should be near to that. Whatever is actual value of y, prediction should be near to that. Actual value of y, prediction should be near to that. In fact, any gap between them I can consider as error. Any gap between them is error in the prediction. Model M1 is making less error. Model M2 is making a lot of error comparatively. Comparatively, M2 has more error. That's why all of you told model M1 is better, isn't it? That's what we thought. Because if the model is good, whatever is actual, it has to be predicted. If actual is 27,000, predicted is 26,000, error is 1,000. Sometimes the error is positive, sometimes the error is negative. Here is minus 1,000 because prediction is higher. Plus 1,000, 0,000, no error. Like that, there are some points where the error is positive. There are some points where the error is negative. What we have to do for a good model? What should be this whole error for a good model? What should be this whole error for an absolutely perfect super duper model? What should be this error? Super duper absolutely perfect model. This error will be 0. But in reality, is that possible? Absolutely 0 error. In reality, it may not be possible. So this error has to be as less as possible or the minimum error. However, the error sometimes positive, sometimes negative is there. Generally, we don't take sum of errors. We take sum of squares of errors. So for a good model, sum of squares of error. What should be the value for a good model? For a good model, sum of squares of error should be near to 0. If you take the squares of all these predicted values, this is known as sum of squares of regression predictions. If you take the sum of squares of these values, these are known as sum of squares of total. So there is some theory which proves that sum of squares of total equal to sum of squares of regression predictions plus sum of squares of error. For a good model, sum of squares of error should be near to 0. Let me ask the question differently. For a good model, what should be sum of squares of regression? Sum of squares of regression for a good model, what should be this value? It should be almost equal to sum of squares of total. That means I am trying to say that actual should be almost equal to prediction. Last question. What should be sum of squares of regression divided by sum of squares of total for a good model? If I take the fraction of the sum of squares of regression divided by sum of squares of total, for a good model, this should be near to 1. Focus on the sum of squares of regression divided by sum of squares of total. This is known as a measure called R squared. So for a good model, R squared value should be near to 1. R squared is the model validation measure for regression. How R square is calculated? Easy. You have sum of squares of error, sum of squares of regression, sum of squares of total. Sum of squares of error should be near to 0. This whole theory finally boils down to SST equal to SSR plus SSC. This should be near to 0. That means SSR should be near to SST. SSR divided by SST is known as R squared, which is equal to SSR divided by SST. That should be near to 1. R squared value, SSR by SST, is the model validation measure for regression. Model validation is done by using R squared. R squared is sum of squares of regression divided by sum of squares of total. For a good model, what should be the value of R square? For a good model, what should be the value of R square? For a good model, the value of R square should be near to 1. The general industry benchmark, if you are building a model in real life scenarios for any client or something, at least look for an R square which is above 80%. If you are building a model your model should have R square above 80%, okay, greater than 80%. Above 80% is the general industry benchmark for a decent model, R square above 80%. Because perfectly 100% R square, perfectly 1 R square may not be possible in real life scenarios, okay. When you are building the model, have a benchmark of at least 80% R square. You have already built your model. What was your first model that you built? Using promotional budget, you have predicted passengers. That was your model M1. Can you tell me, was that a good model or not? Can I believe the predictions because you gave me prediction as 36,000 and all that? Can I believe your predictions? Can I go ahead with some confidence? Can I believe your predictions? Is it okay? Is it a good model? Go to your output summary, check the value of R square based on R square and tell me. Go to your summary, all of you, go to the output summary, browse through it once again. Tell me the value of model R square. What is the R square value of the model? R squared value of the model is 0.933. 93.3% is the R square. Verify it once again, all of you. Promotional budget versus passengers. The previous model that we have built has an R square of 93.3. Is it an indication of a good model? Yes. Which means the predictions that are given by this model, I can take them seriously. I can trust those predictions. Yes. Let me challenge your model. I want you to build model M2 here. This time take intermetro flight ratio, predict passengers. If you have to make a call between M1 and M2, between these two models, which model is the model that you are going to focus on? Which is the model that you will focus on between these two? Which model is better? Build model M2 and tell me, compare these two. Tell me which one is the winner out of these two. Who is the winner? Why model M1 should be chosen? Tell me. Why model M1 is better? Because model M1 has relatively significantly higher R square compared to model M2, who has an R square of 0.242. Definitely, there is absolutely no doubt in our mind that if I have to pick one out of these two models between M1 and M2, I would rather go with model M1. The predictions will be given by model M2 as well. See, any variable can give the prediction. But the thing is, the respect of the model increases or decreases based on R square. So immediately after model building, what is our immediate job? Model building only a part of the job. Model building is only half of the job. Anybody can build the model. Any variable can be used for building the model. Immediately after model building, what should I focus on? Model validation. R square is one such validation technique or validation measure. What is the general industry standard that we should look for? Basic. How much? When you reach what value of R square, you can say I have a decent model which can be used for the prediction. General industry benchmark is R square should be 80% minimum. 80% or above. That is a basic benchmark. There are yet few more measures that need to be discussed. But before that, we will take a quick break. Then we will regroup and discuss the rest of the measures in the regression outward. Before going to the break, are there any questions on whatever we discussed until now? Please let me know. Okay. If there are no questions, then we will take a quick break now. Let us meet at 3:25 p.m. and then continue the discussion on this. Okay. Welcome back. When you are back at your desk, please send me a message. Looks like there's only one person. We'll wait for others to join in. All right. Looks like everyone is back. Before I go to the next slide, I would like to take the questions. Are there any questions on whatever we discussed until now? Whatever we did until now, it was like this. We were trying to predict the passengers using promotional budget. But that was in isolation. We tried using intermetro flight ratio as well, but that was also in isolation only. We used x1 versus y. We used x2 versus y. But you know what? In reality, it's not just the promotional budget that will impact the passengers. The number of passengers is a sum total effect of promotional budget along with intermetro flight ratio, along with service quality score, along with x4, x5 and so on, xk variables. All these xk variables put together should be used for the prediction of the y. Do you agree with that point? It's not just the promotional budget. It's along with the promotional budget, along with a certain combination of intermetro flight ratio, along with a certain combination of service quality score, along with all the combinations, we should predict the passengers. Until now, whatever we have done is known as simple regression or simple linear regression. Linear because it is straight line, or simple regression. But in reality, multiple variables are used, or multiple variables need to be used for the prediction of the target variable y, which is known as multiple regression. Simple regression equation is y equal to beta naught plus beta 1 x. If you have only one variable x, if you are trying to predict the target variable y, this is your data and this is the line that you built. This is the regression line y equal to beta naught plus beta 1 x. However, if you have variable x1, if you have variable x2 third dimension, and there will be points here in this plane, 3D plane, then you may have to form a regression line which is in 3D, isn't it? The equation of that would be y equal to beta naught plus beta 1 x1 plus beta 2 x2. So this is the regression line for two variables x1, x2 versus y. If you have three variables,
So it should be a plane, right?
it's a plane. It's a multi-dimensional plane. That is with two variables, this one. If you have three variables, y equal to beta naught plus beta 1 x1 plus beta 3 x3. We cannot draw the diagram But in mathematics, multiple dimensions do exist. If you have k variables and so on plus beta k xk. So this is a regression line equation. Though it is a multi-dimensional plane, it is still called as a multi-dimensional regression line. It is known as multiple regression line equation. The equation is y equal to beta naught plus beta 1 x1 plus and so on plus beta k xk. This is the multiple regression line equation. Maybe with just one variable, if you are getting 30% R square, by adding several relevant variables, you may push that up to 80% R square. Or maybe with one variable itself, you are getting 90% R square. By adding a couple of more relevant variables, you can push it to 91 or 92, 1 or 2% more, you can push it. But in reality, giving multiple dimensions is the most general thing, isn't it? What do you think? Is it in reality, are we going to use only single variable for the prediction of target value y? Or do we need to use a set of variables for the prediction of the target value y? Real world is multivariate. Multiple factors, multiple features will impact the target y. In reality, you will be building multiple regression models. What is the difference in the syntax? This is how it looks like. Earlier we wrote y tilde x, now you write y tilde x1 plus x2 plus x3 and so on plus xk, mention all the variables. This is not really a literal summation. It is a way to tell Python that use all these x variables for the prediction of the target variable y. In return, Python will use OLS and it will give you beta naught, beta 1, x2 coefficient and so on. Xk coefficient will be returned to you in the output. The concept of calculation of these beta values will be the same. R square concept, everything remains the same. However, we are using multiple variables for the prediction of the target value y. You can think this as extension from single dimension to multiple dimensions. Earlier, you have the data like this. You have some points above and below the line. Now you have some points above and below the plane. You adjust the plane in such a way that it goes through most of the points in the data. The same thing will be done. Beta naught, beta 1, beta k, all these coefficients will be given to you. This is known as multiple regression line. This is the model that we will be using from here on. Go ahead, execute this code snippet, go through the output, tell me what are your observations when you look at this output. From this output, what are your observations? As we discussed, what is that one important measure? Immediately when you look at the summary, our eyes should be focusing on. What is the first measure? All our eyes should be focusing on what? One most important measure in the summary is the R squared value. How much is the R squared value? It is around 95%. Yeah. And you will see that multiple coefficients, some of the coefficients may be positive, some coefficients may be negative. Depending on the nature of the variable, the coefficient values will depend on that. Now look at this carefully. Imagine that I have built a model. To predict the target variable y, I have used x1, x2, x3 and so on. Let's say I have 30 variables. I have used all these 30 variables because my data set contains 30 variables. This is my data. In this data set, there are 30 variables. I have used all of them for building the model. Is it necessary that all these 30 variables should be there always in the model? Or is it possible that there is a variable in the data, but it is not useful for the model? It doesn't have the predictive power. There are a couple of variables, there are a set of variables. They are there, their information is there. But from the model building point of view, from the prediction point of view, those variables are not useful. Is it possible that some variables are not impactful on Y can be removed from the model? Just that a variable is available in the data, it doesn't necessarily mean that it should be always used in the model. For example, if I am predicting the risk associated with a customer, do I really need to use his mobile number? Let us suppose I have his mobile number. We have a column called mobile number. Do you think customers whose mobile number is starting with 9, these are very risky? Customers whose mobile number starting with 8, they are not so risky. Starting with 7, again they are risky. Will it happen like that, or the customer risk associated with the customer loan paying back ability versus mobile number, it has nothing to do? What do you think? Do you think we should use mobile number in model building? There's a numerical value with that variable is available. Is there any use of using such that variable? Whatever is the mobile number, it doesn't really matter. So there will be some variables in the data. It is very obvious. Always you will have certain list of columns. They may not be impactful. And how do you get to know whether a variable is impactful or not? Individual impact of the variables. When you are building a model, when you are predicting the target variable Y using rest all variables x1, x2 and so on xk. Out of these variables, is there any variable that is impactful? Is there any variable that is not impactful? Let's say if I take any general variable xi, whether it is impactful or not, how do I get to know? In the presence of all the other variables. If it is in isolation, I can actually look at the correlation and all that. But in the presence of all the other variables, in this model, is this variable impactful or not, is my question. Is there any statistical measure that will tell me whether a variable is impactful or not? Yes, there is a statistical measure called p-value. Okay. P-value is the statistical measure. There is a hell lot of calculation behind the scenes. I am not going through that exact derivation of the p-value. Okay. So there is something called p-value which can be calculated for every variable. If for a variable, if the p-value is less than 0.05, that variable is impactful. I'll show you how this can be verified. If the p-value is greater than or equal to 0.05, that variable is not impactful. So behind the scenes, p-value is calculated by using t divided by standard error of t, etc., etc. Finally, p greater than or equal to t. In the output, p greater than or equal to t is the p-value that you will find in the summary. This is calculated for every variable. If the p-value is greater than or equal to 0.05, that variable is not impactful. That means whether you keep that variable in the model or whether you drop it out of the model will show you same accuracy. That means it's not a really useful variable. By looking at the p-value, you can decide that. Instead of going to the detailed theoretical explanation of the p-value, I'll tell you a easy way to verify whether p-value works or not. Okay. Go to your latest output. Look at the p-value of each and every variable. So we have used 3 variables here: promotional budget, intermittent flight ratio, service quality score. Out of these 3 variables, is there any variable? So you have used y versus x1, x2, x3. Out of these 3, is there any variable whose p-value? So what are the limits for p-value that I told you? P-value less than 0.05, that variable is impactful. Greater than or equal to 0.05, not impactful, not good, not impactful. Is there any variable which is not impactful or all of them are impactful? Go through the output. P-value, p greater than, this is the one that is called p-value. Check that. Every variable's p-value, check them. Is there a variable whose p-value is greater than 0.05? 0.05 or greater than p-value. Intermetro flight ratio is the answer, is it? What is the p-value? Precisely how much is the p-value for intermetro flight ratio? How much is that? 0.350, which is obviously greater than 0.05. This variable is not impactful. According to p-value theory, intermetro flight ratio is not impactful. Imagine I'm a layman. I don't understand all these p-value theory. You still need to prove that this variable is not impactful. Do you have any other way of proving it? This variable is not impactful. Can you use any other measure other than p-value? Try to just to explain it to me that this variable is not impactful. Is there a way to prove it? Any idea, anybody? This variable is not impactful. That means whether it is in the model, outside the model, doesn't matter. The model is not really impacted. How to prove that this variable is not impactful? Think about it. Anybody, any idea? Any idea? When do you say variable is not impactful? If the variable is there in the model, whether that is not there in the model, doesn't matter. Right now, with the 3 variables, what is the model accuracy? What is the R square value? With the 3 variables, what is the R squared value? What is the R square value with 3 variables? It is around 95%. Now, if I'm saying this variable is not impactful, what should happen? Tell me, what am I going to do? Consider this as model 1. I'm going to build model 2. This time what I'll do, I will rebuild the model with only 2 variables, x1 and x3. If this statement is true, if it is true that this variable is truly not impactful, what should happen? What is the expected R square of model 2? What is the expected R square of model 2? If that variable is truly not impactful, R square will almost remain the same, something like 94.5 or something like 94.6, something like that. Almost same R square is retained, isn't it? Otherwise, R square should drop significantly, isn't it? Do you agree with that point? If a variable is not impactful, whether it is in the model or outside the model, I will get the same R square value, almost same. Check that R square with 2 variables. Now drop intermeter of flight ratio out of the model. Use these 2 variables. Tell me what is the new R square value. Is it almost same 94.5 or something? Slightly near to this? Yeah, 95% almost. Is it fair to say this variable is not impactful? Now you have model M1 which is using 3 variables which is giving you accuracy. Let's say you have model 1, let's say it is using 20 variables giving you 90% accuracy. You have model 2 which is using only 12 variables which is giving 89% accuracy, 89.5% accuracy. Which model would you go for? 20 variables with 90% accuracy, 12 variables with 89.5% accuracy. Which one is beneficial for you? Which one is easy to maintain? What do you think we should prefer? Simple and effective models or complex models with the same accuracy? Usually when you are
12
handling the
variables is better because I
usually
mean, even if we, yeah, sorry.
yeah, please go ahead.
Yeah, I
Please
mean,
go ahead.
12 variables and 20 variables, difference is very less. Had 20 variables given me 99%, then probably it would have made sense. But from the
Exactly.
time being, the difference being so nominal, let's go with 12 variables.
Right. Usually this is preferable. Usually a difference of 0.5 is not even considered as significant. 90 is almost same as 89.5 in real world. This is not a significant difference. When there is 5 points or more difference, then you will say it is significant. There is an insignificant difference, whereas here I am using only 12 variables. Simple and effective models are preferred. You have to collect less data, you have to clean less data, you have to explore lesser data. Still you are getting the same accuracy as 20 variables. Usually 12 variables which are giving almost equal accuracy as 20 variables. This is preferred in general real life scenarios. Okay. So usually we would like to pick and choose only those variables that are really impactful. Individual impact of the variables can be measured using a measure called p-value. If the p-value is less than 0.05, that variable is impactful. You should keep such variables. P-value is greater than or equal to 0.05, not impactful. You can drop such variables. This particular phase of model building, where you are selecting the features that are only impactful and you are dropping the features that are not impactful is known as feature selection or elimination, whatever it is. You're eliminating few features which are not impactful, or in other words, you're selecting few features that are impactful. It is true that when we are starting the problem statement, there can be so many features. When you are actually starting the problem statement, there can be so many features. But it is not true that all those features are impactful on the target value Y. It is our responsibility to filter out the features that are not impactful and then keep only those features that are actually finally impactful. Right? This is known as feature selection and elimination phase. Any questions on this? All right. The next topic is adjusted R square. Along with R square, there is one more measure called adjusted R square. Whenever you are looking at R square, just below it, there is one more measure called adjusted R square. I think some of you have observed it. You thought of asking it, but anyway, you thought that it will be discussed later on. Have you observed it? Adjusted R square, just below R square. There's one more measure called adjusted R square that has been given in the output. Let us discuss what is it. Usually people don't pay attention to this, but there are some specific cases where adjusted R square can be handy. So I'm going to tell you what is adjusted R square, how can you use this adjusted R square. To understand the concept of adjusted R square, I have created a small simulated data, ADJ sample. This is not any original data set. Just to explain this concept, I have created it. What I want you to do is import this data. What I want to do here is I want to predict target value Y using x1, x2, x3. Let me call that as model 1. For that model, find the R square value and adjusted R square value. Tell me what are these values. Build model 2, Y versus x1, x2 and so on 6 variables, R square, adjusted R square. Model M3, Y versus x1, x2 and so on 8 variables, R square and adjusted R square. So tell me the values of R square and adjusted R square for these three models. First model uses 3 variables, second model uses 6, third model uses 8 variables. First tell me these results, then I'll tell you what is the meaning of adjusted R square. Okay, go ahead, give me the answers. So what you'll observe here is When we increase from 3 to 6, R square increases. From 6 to 8, R square further increases. Whereas adjusted R square, 3 to 6, adjusted R square decreased from 56, it has gone down to 37. From 6 to 8, further decreased. So what is this R square? What is this adjusted R square? Let us see. This R square has some problems, especially when you have large number of columns. If you have more features, R square has one big issue. Generally, people don't get to know that, that's why they ignore it, and most of the times it's okay to ignore it. But there are some specific cases we need to be little careful. Let me tell you what are those cases. Let's say you're building a model y versus x1, x2, x3, and so on, x10. 10 variables you have used. Using these 10 variables, your accuracy is R square is 80%, let's suppose. When you add 11th variable, look at this statement carefully. When you add the 11th variable, if that variable is impactful, then R square will increase significantly. It will be 84%, 85%, 86%. If the variable is not impactful, if this variable is not impactful, if it is a junk variable with respect to y, it has no impact, then either R square will remain the same or increase insignificantly, almost 0.1% only change. But R square, what it cannot do is, R square will never decrease. No matter what you add, if you have these 10 variables, 80 will be intact. Unless until you delete one of these 10, then only 80 will be reduced. If you have these 10, on top of it, if you add anything, R square will be either 80.01 or something, or either 80, but it will never reduce. It will never go down to 79 given these 10 variables in the model. Now, sometimes that can be an issue. Let me show you why. When I added the 11th variable, which is junk variable, which is not at all related to y, still R square is increasing insignificantly. I added 12th, 13th, 14th, and so on. I have added 200 such features. 200 variables I have added. Please observe that adding a variable that is related to target variable y is difficult. Is it difficult to add a junk variable, some random value? Is it difficult to generate some random value in a column? Not at all difficult. Bring any junk variable, absolutely no problem. Bring all the junk variables x1, x11, x12, x13, and so on. 200 variables I have added. R square increased from 0.8 to 0.x and so on. R square is now 100% with all these 200 variables added. Is it really true that the model is really 100% perfectly accurate, or the real accuracy of the model is 80% only? Tell me, what is the real accuracy of the model? Is it really 100% accurate? It's a kind of, we have cheated the formula of R square. At the end of the day, it's a mathematical formula. So we have cheated the formula of R square, and then somehow we make it look like 100%. That doesn't really reflect the true accuracy of the model. The true accuracy of the model is still 80% only. So this is a problem with R square. What is the problem? R square can never decrease no matter what you add. It can either stay same or increase slightly or increase significantly. Everything is on the positive side only. R square will never decrease. Now what is the solution for it? And this is a problem if you have too many features. Too many features. If you have lesser number of features, then there is no problem. If you have too many features, R square may be deceptive. It may show a higher value, but it is not truly reflecting the accuracy of the model. In practical scenarios, maybe if you have more than 30 features, you need to be careful. When you are working on problems, based on my experience, I can tell you nearly 30 features or more, you need to be careful. Otherwise, you can ignore this. If you have too many features, then R square seems to be giving you a very high number, even though you have junk variables in the model. That is why there has been some adjustment that has been done to original formula of R square, which is known as adjusted R square. Adjusted R square has been derived from R square only. It is simply a penalty factor that has been subtracted from original R square. What does adjusted R square do? When you add a new variable, Adjusted R square will increase only if the variable is impactful. If you are adding a junk variable, adjusted R square will actually decrease. If you are adding too many junk variables, adjusted R square may actually go down to 60 or even 40%. That is the correction that has been done, or adjustment that has been done to the original formula of R square. Adjusted R square formula is this full one derived from R square only. So adjusted R square is specifically useful if you have too many features. And when do I say it is when, how many are too many? In general thumb rule, you can take more than 30 features. There is no such exact 30 given in any publication. This is just based on the general experience. Then R square, adjusted R square come into the picture. So how do you use this adjusted R square in real life scenarios? Pay attention. You know what you need to do? You build a model. For that model, you check the R square. Let's say R square value is 92%. Immediately after checking R square, you focus on adjusted R square. Let's say that is just 70%. By looking at this R square, this adjusted R square, as a data scientist, what should come to your mind? Tell me, what do you observe? What does that mean for you? How do you take this? R square is 92. There are some unimpactful variables, isn't it? Non-impactful variables, which are known as junk variables or non-impactful variables in the model. If there are junk variables, if there are non-impactful variables in the model, is there a way to check whether a variable is impactful or not? Is there any statistical measure that you can use to check whether a variable is impactful or not? Can you solve this? Is there a way to check whether a variable is impactful or not? You can check whether a variable is impactful or not based on the p-value. The p-value is less than 0.05. You can keep such variables. Greater than or equal to 0.05. You can drop one by one like this. Usually, if you have taken care of this, then this situation will never arise. But usually, if you are using all the variables without checking whether they are impactful or not, then this may come. You can use adjusted R square as an extra internal validation measure. Extra validation measure. But when does it come into the picture? When you have more than 30 features. Usually, for most of the problems that you are going to solve, your R square and adjusted R square will be almost same. 1%, 2% difference is not very significant. When do you say this difference is very significant? In general industry, the significance of the difference is considered when you have more than 5 percentage points difference. That means if R square is 92, adjusted R square 90 is fine. Adjusted R square 89 is fine. Adjusted R square 88 is also fine. Anything below 87, then you will say there is a significant difference. Usually 1%, 2%, 3% difference that is expected with the real data, that is not considered as a significant difference. Usually they too go far away from each other when you have more than 30 features. That is the reason why a lot of people don't pay attention on this. If I am already working on a data set which has only 10 variables or 15 variables, most of the times my R square and adjusted R square will be almost same. Only when there's a difference, then I have to quickly focus on whether there are any variables that are not impactful. That is the use of adjusted R square. You can consider this as an extra additional internal check. At the end of the day, in the final report, you must mention R square only. Nowhere you will bring up the discussion of adjusted R square. But before finalizing R square, you have to make sure that R square and adjusted R square are nearby. That means there are not many junk variables in the model. That is the story of adjusted R square. Suppose that you are building a model. Let us take one more example. Imagine that you are predicting regional sales. And the features that you are using are, let's say, X1, income in that region, average income in that region, X2, average expenses in that region. X3, percentage of male in that region. X4, percentage of female in that region. Like that you have features. Go ahead, build this model, print the output. Tell me what are your observations from the output. All of you, take this new case. Let me know what are your observations. Let's go to the output. So you'll get this as the output. From the output, what do we tend to observe usually? Let us see. Tell me what is the first thing that we have to observe whenever we look at the summary. What is the first thing that we are going to focus? So this is the output summary. Immediately, where should we focus on? We have to ask the overall large question. Is this model good or not? Overall, is this model a good model or not? Is the first question, isn't it? Yes or no? So we will be focusing on R square. R squared value is 84.5. What does that mean? Is it a good model or not? Overall, this looks like a good model. Immediately after looking at R square, sometimes your R square can be deceptive. We need to be careful. Immediately after looking at R square, where should we focus on? After looking at R square, what is the extra internal measure that we should focus on? Adjusted R square. And what should be value of adjusted R square for a good model? For a good model, what is the desired value of adjusted R square? It should be almost same as R square. Is this almost same or is it a significant difference? Look at this R square, adjusted R square. Almost same. Almost same as R square. After this, what do we observe more? What are the other things that we can focus on? Overall model level, R square looks to be good, adjust R square passed. What can be the next level of checks? What are the other things that we observe? Whether a variable is impactful or not. So look at the p-value. Based on the p-value, are there any variables that are not impactful? Are there any variables that are not impactful? Looks like average expenses who has a p-value of 0.197, which is greater than 0.05, average expenses is not impactful. Not only that, you can also see the sign average income as a positive sign. That means as this increases, target variable sales increases. This has a negative sign. As this increases, it has an inverse relationship with the target, which is sales. Percentage male has positive sign. The sign will also tell which direction the variable is related to the target. Imagine this is the model that we have built and we are giving our results to client. And we told the client that we can predict regional sales with good confidence. If you give me income, expenses, percentage male, percentage female in a region, I can predict our product sales in that region. I can be very confident I am getting almost like 84.5% R square, which is pretty good. Above 80 is considered as a good model. That is first point that we made. Point number 2 that we made is average expenses is not impactful. So if you take our regional sales, average expenses in that region has no impact on the regional sales. If it has any impact, it has a negative impact, which means as average expenses increase in a region, our regional sales goes down. As average expenses decrease, our regional sales goes up. That's what we told our client. And the client is validating us. He's giving us what is his opinion. You know what the client told? Here your analysis is true. Yes, you can predict regional sales given the income, expenses, percentage female, percentage male. It is true that you can predict regional sales. These are pretty good indicators. In fact, these are the ones that will tell what will be the sales in a region. Yes, this statement is correct. The second statement is utterly wrong. Your second statement has a huge problem. You told that average expenses has no impact on regional sales. I can't believe it. Because in my experience, in my whole, whenever I'm running this business, I'm there here from product inception. What I have seen, imagine I'm your client, okay? What I have seen is average expenses are the most impactful variable on regional sales. If in a region, if average expenses are high, then there our sales will be high. If in a region average expenses are low, there our sales will be low. And you're telling me there is a negative impact? That means if in a region average expenses is high, if everyone is spending, then you're telling me our sales is low. How is that possible? Otherwise, if everyone is not spending, if average expenses are low in a region, then your sales is, then now you are telling me that our sales is high. How is that possible? If nobody is spending, how can we have increased sales? It is totally baseless. Your second point is totally wrong. It is not making any sense from the business point of view. That's what the client told us. We are kind of totally shocked because we have used the same data given by the client. Before coming into the data, what did we do? Before coming into the model, what did we do? We did the data exploration, data validation, data cleaning, everything we have done. Using that data, cleaned data only, we are building the model. And these results are the ones that we got. We start the investigation, let us suppose. Remember, these are some of the practical issues. You will have such counter intuitive results which are not matching with the business logic. You need to know, we need to have the skill of how to actually investigate these kind of problems. Because general regression and all that in any theory class you will learn. That's not really difficult. When you actually start solving the problem, these are the questions that we get from our clients. These are the discussions that we have on every weekend, and we have to resolve all this. So here is a situation where we are expecting a kind of direct relationship with a variable, with a target, but it is giving counterintuitive results. First of all, it has to be impactful, but our model is showing it's not impactful. Secondly, it has to be positively impactful, but our model is showing it is negatively impactful. What's wrong with this? Let us suppose we are doing different type of investigation, different variations of the model, different permutations, combinations of the model. Let's say at a particular place, we reached, in a particular iteration, we reached to this phase where we are ignoring average income just for the sake of investigation. Ignore average income, use average expenses, percentage male, percentage female, only 3 variables, use them. Rebuild the model. All of you, go ahead, try to predict regional sales using 3 variables. Tell me what are your observations from that output. So this will be the new output. You ignore average income, take average expenses only. From this new output, what do you observe? First thing, what do we observe? First thing in the output, we have a habit. What is our first thing that we have to focus on? Always go to R square. Is this R square same as the previous model, or is there any significant difference? Is it same as the previous model, or is there any significant difference? Previous model 84.5 versus 83.8. Is it okay? One or two difference is expected in practical scenarios? Almost same. So we have almost same equally effective model. But where is the huge, significant, where is the monumental change that we have seen in this model? What is that we have seen in this model that we need to highlight, which is kind of almost shocking? The p-value of average expenses is 0, which tells me that average expenses is impactful. That's what the client told, and now it seems to be impactful. What is the other thing? Average expenses has a positive coefficient, isn't it? Average expenses has a positive coefficient. A while back, we told that if expenses increase, regional sales decrease. But now we are saying that if expenses increase, regional sales increases because it has a positive coefficient. If expenses decrease, regional sales decreases. Tell me one thing. From this model to this model, have we gone to the data and made any changes in this column of average expenses? Have we made any changes in the target column Y? Was the data tweaked? Was the data changed? Or did we use exactly the same columns and the same data? Did we tweak the data? Did we go to the data set and changed it? Can you verify the data set name? We have used exactly the same data set name, previous model and this model. There is no cheating here. In fact, all of us have downloaded the data only once. All of us have imported only one data set, regional sales data. We are using that data only. We are using the same columns. If we are using the same data, same columns, how can you say sometimes it is positively impacting? Sometimes it is negatively impacting. What is this? This is totally against the business intuition, isn't it? This is not how it is supposed to be. We cannot tell the client that in one meeting we are saying average expenses is positively impacting the regional sales. In other meeting, we cannot say it is negatively impacting because maybe we might be building some strategies on this. Why all these discrepancies are happening? What is the issue here? Remember, this is a very common problem that you may also face in your future. These kind of problems usually occur if there is some interdependency between these variables. If there is any interdependency between the x variables when you are predicting the target variable y, if you are using x1, x2, x3 and so on xk, if there is any interdependency, maybe one variable is related to two more or three more variables, then you may get these kind of issues. The beta coefficients cannot be trusted. The p-values cannot be trusted. That kind of interdependency between the variables is very common. It will lead to all these issues. This particular problem is largely known as the problem of multicollinearity. Multicollinearity is a very common problem while you are building the models. Multicollinearity, what is multicollinearity? When you are trying to predict target value y using x1, x2, x3 and so on xk, some of these variables, maybe x1 is related to x2 and x3. Maybe x1 is related to x5. Maybe x1 is related to x6, x9, x12. One variable is related to either one or multiple variables. This is known as the problem of multicollinearity. For example, if I take income is the first variable, look at this in our list, average income, average expenses. If I take income of a person versus expenses, it is true that if a person has very high income, his expenses seems to be very high. In general sense, if you take any portfolio in this world, if a person has high income, his expenses will be high. If a person has low income, his expenses will be low. Is it fair to say that these two variables are definitely related to each other? Or are they independent? No matter how much earning I'm making, the expenses are dependent on this. What do you think? Are they dependent or independent? Definitely related. In fact, in most of the portfolios, what you will see is your expenses is around 0.65 into income. We tend to spend minimum 65% of whatever we are earning in a month for sure. Immediately we spend it. Maybe remaining ones we spend slowly, but 65% of it we are going to spend immediately. If I take percentage of male in a region, if I take percentage of female in a region, are they independent or related to each other? Let's say if percentage of male is 55, what will be percentage of female in a region? In a region, I told percentage of male is 55%. What is the percentage of female? Roughly around 45% only. In a region, if the percentage of male is 60%, percentage of female will be 40, isn't it? Can I say these two are independent of each other or they are very much related? One is just 100 minus, if percentage of male is X, percentage of female is 100 minus X, isn't it? Is it fair to say percentage of male and percentage of female are very much related to each other, or these two are independent? Maybe whatever is this, it doesn't really matter on this. These kind of issues. Let's say I have two variables x1, x2 in my model. When I looked at their definition, first variable is income in dollars. Second variable is income in rupees. Are these two different variables or it is just one variable expressed in two different units? Are they independent or are they related to each other? Income in dollars. If income in dollars is high, income in rupees will also be high. Income in dollars low, income in rupees will also be low because income in rupees is some 66 or 67 times the dollars one. Agreed or not? If you have these kind of interdependency, if you have these type of interdependency in the data, in the features, this is known as the problem of multicollinearity. This need to be detected. This need to be eliminated. I'm going to tell you how to detect, how to eliminate it. But I gave you what is the meaning of multicollinearity. Have you intuitively understood what is multicollinearity? One of the most widely asked interview question, what is multicollinearity? What is one line answer that you can give? Multicollinearity. What is multicollinearity? The interdependency between the features, interdependency between the x variables, interdependency between the predictor variables. One or two features are related to each other, or more than two features are related to each other. That is known as multicollinearity. This multicollinearity need to be detected, it need to be addressed, and it's a very common problem across all real projects. Okay. For example, let's say I have built a model y equal to, let's say, x1 plus 2x2 minus x3. This is my final model that I got. I know there was some kind of multicollinearity. X1 and X3 are related to each other, but I did not pay a lot of attention on this. I thought, what's wrong? Let me go ahead and take X1 as well as X3 for the model building. I did not pay a lot of attention to this. I kept on building the model. This is the result that I got. Y equal to X1 plus 2x2. This minus x3, I'm rewriting it as plus x3 minus 2x3. Equation number 3. Look at equation number 1 and 3. Are they same? In equation number 1, I wrote minus x3. I am rewriting it as plus x3 minus 2x3. Which means what? 1 and 3 are same. Confirm that to me. Verify it and tell me. Is 1 and 3 same? Technically, equation number 1 and equation number 3 are same, isn't it, mathematically? Y equal to x1 plus 2x2 plus x3. What is minus 2x3? What can I substitute there in the place of minus 2x3. In the place of minus 2x3, I can substitute minus x1 according to equation number 2. Minus x1 plus x1 will be cancelled out, y equal to 2x2 plus x3. This is equation number 5, which is technically equivalent to 4, which is equivalent to 3, which is equivalent to 1. Equation 1 and equation 5 are mathematically same equations, equivalent equations. No difference between them. However, if I look at the variable relations, the relationship between x3 versus y according to equation number 1, what is the relation? Is it a positive relation or a negative relation? X3 has what impact? Positive impact or a negative impact? X3 versus y according to equation number 1. X3 in equation number 1 has a negative impact on y. Whereas if I come to a mathematically same equation, equation number 5, what is the relationship of x3 versus y? Is it having a positive impact? Is it having a negative impact according to equation number 5? X3 versus y in equation 5. Is it positive or is it negative? Since it has a positive coefficient, we can say it is having a positive impact. According to equation number 1, what is the relationship between x1 versus y? What is the relationship between x1 and y? There is a positive relation. According to equation number 5, what is the relationship between x1 versus y? Where is x1? x1 itself is not here, which means if x1, if a variable itself is not there in the equation, is it fair to say there is no relation? Sometimes we are saying negative relation, sometimes we are saying positive relation in the same equation. Sometimes we are saying positive relation, sometimes we are saying negative relation. All contradictory results. What is the major reason for all these contradictions? Tell me which equation is causing all these contradictions? What is that equation because of which all these contradictory results are created? Tell me why there is this contradiction in here, which is equation number 2. What is this? Interdependency between the features, which is known as multicollinearity. In presence of multicollinearity, I cannot trust this. Right now it looks like +1. Sometimes it can be 0. I cannot trust this. Sometimes it looks like -1. It can be +1 as well. It can be any number. Multicollinearity is the interdependency between the features which causes all these issues. Multicollinearity need to be detected. Multicollinearity need to be eliminated. If we leave it as it is, the individual interpretation of the variables may go for a toss, which is a common problem. There are solutions for it, which we are going to learn. Have you understood the concept of multicollinearity? We are not yet done with the multicollinearity, but in terms of what is multicollinearity, have you got the concept? Any questions on this? Please go ahead. Anybody? Very simple question. Simply summarize everything once. Any specific one you want me to focus? Like from the beginning or only multicollinearity you want the summary? Venkat? Do you want me to go through only this equation, is it? the on this slide from equation number 1 to equation number 5? Is that what you want to get an understanding of? Yes, okay. Let us suppose we have built a model y equal to x1 plus 2x2 minus x3. We have three variables, x1, x2, x3. Using them, I have built a model. This is the regression line that I got. Okay. Actually, x1 and x3 are related like this. X1 is 2 times x3. It is like income in dollars, income in rupees, like the way they are related. X1 and x3 are also related, but I did not really care about it. I have gone ahead and built this model. Is this clear? There is a relationship between them, but still I have gone ahead and built this model. This is the result that I got. Okay. Now look at this, y equal to the same model. I am rewriting it this way. Check this. X1 plus 2x2. How can you write minus 1? I am rewriting minus 1 as plus 1 minus 2, which means plus x3 minus 2x3. This is equation number 3. Check equation number 1 and equation number 3 carefully and let me know technically whether equation number 1 and equation number 3 are they same. Is there any difference between them technically? There is no difference, isn't it? Now y equal to x1, they are same. X1 plus 2x2 plus x3. What can I substitute in the place of minus 2x3? Is there another value that I can substitute in the place of minus 2x3? What can I substitute here? In place of 2x3, I can substitute x1. So in place of minus 2x3, I can substitute minus x1. Is there any difference between equation 3 and 4? Technically, is there anything that we changed? No. 2x3 was x1 we did. Now x1 is here plus x1, this is minus x1. We can cancel them. Y equal to 2x2 plus x3, which is equation number 5. Equation number 5 and 4 are same. I just did the cancellation here, that's it. 5 and 4 are same, which is same as 3, which is same as 1. Is it fair to say 1 and 5 are same equations? Is that a fair point? 1 and 5 are same. Now according to equation number 1, what is the relationship between y and x3? X3 has a positive impact or a negative impact on y according to this equation. Look at the coefficient of x3. What is the coefficient of x3? Negative. Is it fair to say x3 has a negative impact on y? Yes. Come to equation number 5. Tell me what is the impact of x3 on y? What is the impact of x3 on y? Positive impact. On one side we are saying equation 1 and 5 are same. On the other side we are saying x3 is having a negative impact, x3 is having a positive impact. Isn't it a kind of contradiction? One day I am saying as x3 is increasing, y increases. On the other day I am saying no, as x3 is increasing, y may decrease. Why these discrepancies are coming? Why? What is the reason for this contradiction? Where is the main culprit? What is the reason? Is it equation 1 or 2 or 3 or 4 or 5? What is the main reason for this issue? Why there is this kind of discrepancy? What is the major equation that is causing all these issues? The interdependency between x1 and x3, isn't it? Because of that only we could rewrite all this. Otherwise the equation would have been fixed, no? Agreed or not? Since there is an interdependency, that's why we could rewrite x3 like this. Yeah? Is it clear? Yeah. So that is the reason why you are getting these contradictory results. The interdependency between the variables, which are the features, is known as multicollinearity. When you have multicollinearity, you cannot trust this coefficient. You cannot trust this coefficient. Same way, you cannot trust this coefficient, you cannot trust the coefficients if you have multicollinearity. Is it clear now? Make sense? You can actually stop me there and then itself while the discussion is going on. I can actually stop there and explain with a different example if required. Okay. Any other related questions, anyone? Any other connected questions to this? What we'll do is we will stop the discussion here for today. Tomorrow, I'll give a quick recap of whatever we discussed today. And there is one more topic of this multicollinearity regression, which we will finish. Then the concepts that we are going to discuss tomorrow will be logistic regression and decision tree segmentation. Okay. Any other?
Thank you. Thank you so much. Okay. Yeah. Bye.
So if you have any more questions, you can stay back. Otherwise, you can drop off. We will definitely meet at 9:30 tomorrow. Thank you for the enthusiasm.
Yeah, sure.
Keep
Thank
this.
you for
Yeah.
the class.
Yeah.
Yeah. Bye-bye.
Bye.
Thank you.
Venkaran, when can we get the recordings of this session?
On Thursday, all the recordings will be collated and it will be sent to your L&D team. I think they are the ones who own this. Even I don't have it in my hand. So somewhere on the cloud they will be recorded. So L&D team is going to download all this and share it on Thursday.
Okay, sounds great. Yeah.
Yeah.
Thank you so much for the session. Thank you so much.